Recording already. Okay, so the first thing we're going to cover, so for your physics, right, the plan is to cover two topics, which is number one is dynamics, and number two is, of course, turning effect of forces. Now, the energy, I know you all you also have the topic in your syllabus, but please go and take a look and read about it. Okay, now, unfortunately, the notes for the physics side, I think there's quite a bit of missing information. So I'll be doing a lot of writing everywhere. So I need you all to find a space or maybe a separate paper to start writing a few things. Okay, I also wrote quite a lot of things on my notes. So I just need you all to find some space, like for example, this empty space to kind of cover what I want to cover today. Okay, all right. So let me start with the first one, which is dynamic, and then we will go through the content, then we will practice some of the questions. So we will go back and forth a bit here and there. So sorry, I will ask you all to flip the notes a bit today. Okay. All right. So firstly, let me talk about dynamics. Now, firstly, dynamics, right? The first thing you all must know, the most important formula that you all need to take note is this one, which is W equal to mg in this case, right? And that is how to calculate weight from mass in this case, right? So W equal to mg in this case. You all know where am I? This notes, physics notes, page 3. Okay, this formula. Now, as you all know, mass, right? The important thing you must take note in terms of definition, they are measured the amount of substance present in a particular body. But weight, you all must be careful because, right, it depends on the gravitational force acting on the body due to the gravitational field, which is G. All right. Now, please take note, what's the difference between mass and weight is that mass, number one, it will never change. So if you go from Earth to Moon and Saturn and whatnot, the mass will never change. It remains unchanged or unaffected. But once you move yourself to Moon, then of course the weight will change because, right, the G on the Moon is very different, right? So the one that you all need to know very well in your O level is this. Your G on Earth is what, everyone? You all should know. Is what? Let me ask Ryan. Correct. 10 newtons per kilogram, or the other unit we use is 10 meter per second square, right? So that's the G on Earth. Now, anything else, take note, they will provide to you in your exam. Okay, if they tell you the G on the, let's say Moon is 3.7, you just use the value 3.7 in this case. Okay, now number two, this one I need to emphasize about the units because, right, confirm a lot of you will make the same mistake when you are doing your calculation. Firstly, W equal to mg, right? M is of course mass, right? Now, first question, let me ask Elmira, what is the SI unit of usually for masses? For mass, what's the SI unit usually? kg, right? So please be careful, the unit here must be kg. All right, if let's say they give you in gram, please go do the necessary conversion. Then of course the SI unit of weight, then Elmira, what is the SI unit, if you recall, roughly? Newton, correct. Because weight, please take note, is a type of force. Force, as you all know, is the unit Newton in this case. So that's why the unit is also Newton. Okay, so please take note. Okay, other than that, I have nothing much to go through about this one. Okay, because that is the formula that you all need to know. Okay, the big one that you all learn in this topic is, of course, your 3 Newton's law of motion in this case, right? Which here, Newton first law, second law, and third law. Now, this one, take note, you are not expected. I saw a big just now I saw something. Okay, but anyway, you are not you are not expected to memorize it. So you all I wrote here, don't need to memorize, no need to memorize. But let me go through the general idea of Newton's first law, second law, and third law. Okay, in general. So this is where the space is not enough. So I'm going to use the empty space on this page. Okay, so if you can find an empty space somewhere, please use an empty space. Okay, so let's write down Newton's first law. Newton's first law. Okay, let's do this. Right? Okay, so what does Newton's first law state? And this one, the keywords are very important. Newton's first law, if you read the page after that, right? I mean, after this, right? They say, an object will always be at rest or in constant motion unless a force is acting on it. So this one, everyone please take note. Newton's first law, the most important thing, take note, is the resultant force is equal to 0. And later we will elaborate about what is resultant force. Okay, for the meantime, just take note. KIV, Newton resultant force is equal to 0. Now, what do I mean by when an object is at rest or constant motion, right? So there are 2 scenarios you all need to know. Number 1, at rest, and number 2 is at constant speed or motion. Constant speed or velocity. Okay, these are the 2 scenarios you all need to know. Okay, now what do I mean by when an object is at rest? So it can be as simple as, if let's say I have a ball on the ground, correct? But I never touch it or anything, it's just resting there. So this is what I mean by an object is at rest. Okay, all right. Now, what is so important about at rest is this. So let's discuss what are the forces acting on an object when it's at rest. Okay, so maybe can I ask, hold on, let me remember. Isaac, is there Isaac here? You are Isaac, right? Okay, any forces that are acting on the ball or by the ball? Correct. So essentially, number one is definitely the weight. Correct. All right. So if you are at rest, you will definitely have weight acting on the ball, right? Now, any other force besides that? To be honest. Because it's at rest. So no movement, right? So cannot be have friction. So what other things you might have? Something about when it come in contact with each other. Anya? Okay. Anya? Anya? Normal force. Why? Why normal force? Because. And how do you draw the normal force usually? Correct. So from the contact point, oops, sorry, I use a different color. Let's say black color. So in this case, you point up in this case. So this is what we call normal contact force, or some of your school might call it reaction force, depending on what your school say. So this is what we call normal contact force when it comes in contact with each other. Now, but the thing is that this is the next question I want to ask all of you. Is the weight and the normal contact force exactly the same? What do you all think? Or different value? What do you think? So let's say maybe the weight of this ball is 3 Newton. Is the normal contact force also 3 Newton? Everyone, what do you all think? Any guess? Anyone? Yes or no? Oh, not or right? Come, everyone. The answer is it must be the same. Normal contact force will always be the same. Because why? Take note. If let's say your normal contact force is bigger, like 5 Newton, wouldn't the ball start floating? Right? Because there's resultant force, right? So the thing is that is the idea of this particular Newton first law. Newton first law means the force acting on it are all equal, and there is this thing what we call a balance force. Everyone please help. Balance force means the upward equal to downward, leftward equal to rightward, etc., etc. Yes, right. Not less, less it will go down. Okay, but if it's more, then it will go up, right? Because the resultant force go up in this case. Okay, so at rest, these are the only two forces that are technically acting on the object in this case, your weight and your normal reaction force. Okay, now, but let's talk about what if, let's say, the object is moving at constant speed. Okay, let's say, imagine I have a trolley here, okay, or a car moving rightwards at constant speed. Let's say I tell you the speed is maybe 10 meters per second. Okay. Okay, constant speed at 10 meters per second. Okay, so what does it mean by traveling at constant speed? Now, this one, I also keep telling my Sec 3 and Sec 4 students, every time you see the word constant speed or constant velocity, the next thing you must tell me is acceleration must equal to 0. All right, acceleration must be 0. Because why? If you all remember, come, Raphael, what's the formula to calculate acceleration all the time? It's called A equal to V minus over T. Correct. What is V? Final or initial? Final velocity, while this one is initial velocity, and then of course this is time. All right. So everyone please say no. If let's say constant speed means acceleration equal to 0. Okay, this is important. Now, then what does it mean by resultant force 0, right? That means whatever the force that is acting by the car, meaning for example, let's say you are the driver, you push the pedal right, you exert maybe 100 newtons on the right. That means the friction is also exactly the same. Frictional force is also equal to 100 Newton. So that at the end of the day, it balances out also. 100 minus 100, resultant force 0, right? And resultant force 0 means acceleration also 0. Okay, so you all must take note of this. Your Newton first law. Okay, sorry. You have the materials. You can write in the chat if let's say you don't have the material. Then I can send you the QR code. Okay. All right. Any questions? Anyone want to clarify anything? Anyway, my class, please ask questions. I'm more than happy to answer your questions. Okay. Any? Question. Okay, so that's it for Newton's first law. Newton's first law, please take note, is all about balance force. The right and the left the same, up and down all the same in this case, right? Now, but that is where Newton's second law will kick in. What if, let's say, the forces are not balanced? So this is where second Newton's law will come in. Okay, Newton's second law, sorry, wrong. Newton's second law will come in. This time round, the resultant force will not be equal to 0. Then means it's unbalanced, the force. Unbalanced force. Okay, so let's go through. There are two scenarios also you all need to know. Number one is when the object is accelerating and when the object is decelerating. These are the two scenarios you all need to know. Okay, accelerating. Okay, then draw the diagram. Okay, there's a reason why important. Okay, ready? Okay, everyone okay? Okay, let's start. Okay, let's say we have an object now not balanced, the force. So maybe let's say again, I decided to push the pedal even harder. Okay, anyway, take note, the car is moving this way. So let's say I decided to push the pedal even harder. Let's say now 200 newtons towards the right. Okay, but the friction still the same. Let's say maybe still 100 lah. Let's say as per usual. Okay. All right. So the first question I want to ask is this. There are two things that I will usually ask students about this diagram. Now, number one, let me ask Destiny. In this case, is there a resultant force at the end of the day? Based on this diagram? Yes. By how much value? 100. Towards where? Left or right? Right. Yeah, right. Okay, so this one, everyone please know, resultant force is 200 minus 100, which means 100 Newton to the right in this case. Right? Everyone okay? To the right. All right. Now, so what if I ask just now Destiny, right? To the right, right? Now, please take note, if let's say the resultant force to the right and the car is moving to the right, let me ask Destiny, is the car here constant speed, accelerating or decelerating? What do you think? No, don't worry, don't stress. But yeah, any guesses? Accelerating, very good. So everyone please say no, the car is actually accelerating towards the right. To the right. Okay, so that is the first scenario you all need to know. Okay, when the resultant force is in the same direction as the car moving or the object moving, then it's accelerating. Okay, right? Okay. Okay, now the next scenario is this. Then I decided to maybe slow down my pushing of the pedal. Let's say same thing, my car moving to the right, right? Moving to the right. But I decided to not push the pedal too hard. Maybe I push until 50 Newton only towards the right. But the friction is still 100 Newton. Okay. Okay, next. Destiny friend, Chandra. Got N behind or no? Got have. So Chandran, is it? Okay, sorry. Chandran, can I ask you, then what is the resultant force here? What will be the value? 50. But towards where now? Left. Very good. So everyone take note, it's now 50 to the left, right? Now, let me ask Chandran, is this car now accelerating towards the right or decelerating? This time around is decelerating in this case. Because why? The resultant force is towards the left, but the car is moving towards the right one. So that's why the car is slowing down or decelerating. Now, common mistake student will tell me is this. They will tell me, oh, the car come to a stop. The answer is no. It will slow down. Because it's decelerating. Decelerating means your car is slowing down. It will not immediately come to a stop. Please take note of that. Okay? Anyway, sorry. Oh, too cold, is it? Sorry. It's not working. Okay, it's working. Okay, okay. Okay, so that's it for this one, the deceleration of the car. Any questions so far? So I repeat, for this particular case, the resulting force is towards the left, but the car is still moving towards the right. So the car is actually decelerating in this case. Yeah. No, it's still towards the right because the car is moving towards the right, but it's slowing down essentially. Okay, so be careful of that. So common mistake, as I mentioned just now, number one, student will tell me the car come to a stop. This is wrong. Immediately. Number two, another problem that students have is they will tell me like what you say lah. It will start to move to the left. Wrong. Also, please take note. All these are very common mistakes that students will write. Okay, because the car is still moving towards the right. Yes. Yeah, slowing down. So, but still moving to the right, but slowing down lah. Yeah, correct. Okay, any questions? Anyone want to clarify anything? No, okay, that's it lah. So that is pretty much it for the Newton's second law. So anyway, just want to clarify one more thing. Please take note, the formula you need to know for Newton's second law is F equal to, everyone, what is it? The formula? Okay, MA, very good. And what is M? Wait, Kieran. Okay, mass, which is what unit? SI unit? kg. And what's A? Very good. Acceleration. And usually what's the unit of acceleration? All right, meter per second square. And of course, force is of course Newton lah, in terms of the units lah. But here, let me clarify one thing. The force here must be the resultant force. Please take note. It cannot be the force that I push the pedal. It's not the case. You must go and resolve what is the resultant force first. Then you can apply this formula. Okay, so please don't whack the formula anyhow. It must be resultant force. Please take note. Resultant force. Yeah, FR. Yeah. But in the notes, I think they put F net lah. So F net means net resultant force. Same thing, meaning the same. Okay, so please take note of that. Okay. All right. Any questions so far about Newton's second law? No, okay, later we'll practice some questions. Later I will highlight some of the key points. Okay, anyway, let's talk about third Newton law. Then third Newton law, this one is just more of a memory work thing lah. Okay, so let me explain a few things about Newton's third law. And this is where the notes will kind of give me the points that I need to discuss. Newton's third law. Now, as you all know, you might have heard the saying, right? For every action, there's an equal and opposite reaction. This is what third Newton law states about lah in this case. Now, but here, I need you all to be very, very careful. How do you apply the Newton's third law? Everyone, please take note, Newton's third law, point number one, they say is equal in magnitude. Correct? Means, as what the meaning say lah, for every action, there's an equal and opposite reaction, right? Then opposite in direction lah. Usually, most students can give me this two. Now, but the other things that you must take note is this. Number one, they act on different bodies. And number two, they are the same type of force. But let me explain the scenario here. Okay, the example that I always like to give students is, what if, let's say, you decide to punch the wall? Right? This is the wall. Imagine this wall. You decide to punch the wall, right? And let's say you punch the wall, right, at maybe a force of, let's say 30 Newton. Let's say, I just whack a number, 30 Newtons in this case. Okay, if let's say I punch the wall, I'm the first body. My hand, right, is the first body. I punch the wall, correct? So I act 30 Newtons onto the wall. Now, the question is, what is the reaction force here? It must be from the wall. Sorry, I use a different color. Maybe use pink. From the wall back to my hand. All right, so there are two different bodies. One is your hand. Oh, sorry, hand. The second body is the wall. In this case, the wall hitting back to my hand. That's why when you punch the wall, what happens? You feel painful, right? Because the wall is acting the same force on your hand in this case. So that is what I mean by equal and opposite reaction. So the wall also exert a 30 Newton onto your hand. So that is what Newton's third law states in this case. Okay, so I repeat, the first scenario is hand to wall. The second one, the action reaction force is from wall to hand. So these are the two bodies that you must take note of. Okay. Any questions? Anyone want to clarify anything? The Newton law? Okay, so later also there will be some questions you all can try lah. Okay, but yep, that is pretty much it for the 3 Newton law. Later, we will take a look at some questions. I want to highlight some of the key important points lah. Okay, but anyway, that is pretty much it. So, anyway, for friction, let me go through very quickly what you need to take note. Friction, right, as you all know, okay, maybe I ask lah. Okay, maybe I ask, alamak, I forgot. Keep forgetting your names. Regina, right? Okay, so what is your understanding of friction usually means? Correct. Slows down movement of an object, right? In this case, right? Now, usually in terms of, let's say, the diagram, what I did was, I did this, right? So imagine, let's say I have a car moving towards the right. Usually friction will be the opposite way, right? Towards the left in this case, right? So that is if you are looking from let's say a big overview of the object. Now, but the thing is that here, I need you all to be careful. And this one, they got test before in O level. So I need you all to put a stop on this one. Now, in O level, they have asked students, right? What if, let's say now, I zoom onto your wheel or your feet in this case? So let's take a look at the wheel case. So this is the car, not car, sorry, what's called a bicycle in this case, right? Now, if you must realize what happened. When let's say your bike is moving in this direction, moving to the left, right? Usually, what you all will tell me is friction must be on the right. That's how you all will tell me. But when I zoom in into the wheel, I need you all to be a bit careful. So let's take a look at the back wheel. In this case, this is what we call a power-assisted wheel. Okay, let me write power-assisted wheel. So what do I mean by that? Meaning, you have to use your leg, right, to pedal to push on the pedal, then the wheel will turn. Okay, so next question I want to ask is this. Geraldine, can I ask you? Not Geraldine, sorry. Regina, sorry. When the bike moving towards the left, how would this wheel rotate? Clockwise or anti-clockwise or clockwise? Correct. It will rotate this way, right? So you can see when it rotates, right, and it touches the ground, right, the friction, you see, is the other way. So I need you all to be careful. Zoom in onto the wheel. You see it rotates clockwise. No, sorry. This one. Anti-clockwise, sorry. Anti-clockwise. So you can see the friction is towards the left. So this is the one that they test very often in O level. So you all need to know this very well. So when the wheel rotate, right, it will rotate this way. So when it touches the, let's say the ground, the wheel or the force is this way. Then the friction is this way. It must be opposite. Correct? So on the ground, the force is this way. Okay? Right. So that is the question they like to ask for O level. Okay. The one that they sometimes do test, I think, I'm not sure about your schools, but sometimes they like to test this one also. This one a bit different because, right, this one, the wheel is freely rotating. There's no pedal, there's no nothing to push it forward, right? So you can see this one is as per normal, as what you all learn. When the object is moving towards the left, the friction is towards the right. This one, don't ask me, because at the end of the day, it's just like, imagine, let's say you are, for guys, you all know what is it called? Leopard crawling. You all know what's leopard crawling? Right? You all know what's leopard crawling? Leopard crawling means literally you go on the ground, you drag yourself. So your hand will be the one dragging your body. But your feet, right? You realize your feet is just following your body. So this is what is happening. This one is being dragged by your hand. This one, your feet is just following the motion in this case. So that's why you can see the friction is on the other side in this case. So this one, please take note. This one, some schools like to test this point. So make sure you all take note of this. Yeah. Okay. Similarly, for your feet, I just let you all know, when you are walking, right, usually what happens? Same thing. If let's say you are walking towards the right, you all will tell me the friction is towards the left, right? But when you zoom to your feet, I just let you all know. When you move your feet, what happened? You touch the ground, then you move up, correct? So what happened? This one, your action is this way, the force. The friction will be this way. Please take note. This one also, they got test before. Okay, so the force going up, because when you drag your feet, you push out, right? So the friction is this way. Okay, so something for you all to take note. Okay, Renzo, okay? Okay, that's it. I'm done with this part. I'm done with dynamics. So the rest of it is mostly pure chem stuff, so you don't have to take note of that. So just make sure you all take note. There's a word here not for combined science. So everything else you all can just ignore for the meantime. Okay, all right. So now there are some questions that I want to highlight to all of you. So where is the question? I think there's a pure chem and this is what? pure physics one, right? Yeah, pure physics. So we skip to the combined one. I'm not sure what page is that on your booklet. There's no page number, right? Yeah, they just put one. Okay, can you all find? It should have this title, Upper Secondary Science Physics. You all can find it? Yeah. Yeah. Ah. I mean, if you want, I can give lah. I don't know whether I can find the access, but I'm not sure lah. Whether I can distribute it. But I can get back to you about this lah. Okay. All right. So anyway, the question that I want you all to try is actually especially question 2. So can you all try question 2 and question 3 by yourself first? Okay. So I give you about probably 3 minutes. You all try. Read the question. It's based on the second Newton law that we mentioned just now. Can you find? You all can find? Okay, next time I will feedback about the pages. You all can find the non-pure one. Okay, question 2 and 3. You can try first. Okay. Is everyone okay with the questions? There's only 2 lah. 2 and 3 only. So it shouldn't take too long about the 2 questions. Okay. All right. So let's pause the time right now because most of you are almost done. Let's take a look at the 2 questions, question 2 and 3. Now, question 2 is the one that I was trying to ask, describe for all of you about the Newton's second law. Now, whenever you encounter this kind of question, if let's say you cannot imagine, please draw what we call a free body diagram in this case. So a free body diagram, right? Very simple. You just need to draw a body, which is a box, and then you just show all the forces acting on the box in this case. So as you can see here, they say the Eskimo pulled the sledge across a horizontal force of 80 newtons, and there's a friction of 20. So as you can see, I drawn out 80 towards the right, for example. I do not know, but let's draw 80. Then 20 friction towards the left on the surface in this case. And then they ask you to find the acceleration of the sledge in this case. Now, one common mistake that a lot of students will do is this. They will tell me, oh, the force is 80, the mass is 50, therefore the acceleration is 80 over 50, which is 1.6 meter per second squared. But this is wrong, right? Because, right, remember this, the force here must be the resultant force. You must evaluate for me what's the resultant force. So here, let me ask a very important question. Renzo, what's the resultant force? Correct. So you must find the resultant force here. Number one, 80 minus 20, which is 60 first. Then you can apply the formula. FR equal to MA. So the A will just be 60 divided by 50, which is 1.2 meter per second squared. So the answer is B. Okay, so I repeat, must find resultant force first. Then you can do all the necessary calculation. Okay, Ken? Any question about question 2? Anyone? Anyone? Clarification? No? Okay, I move on. If it's too fast, let me know. Okay, now question number 3. This one even easier. Because, right, as you can see, they say a force push an object across a frictionless object or surface. Means there's no friction here. You don't have to care. So therefore, you can just apply F equal to MA. But this one, they say acceleration is 2.5, right? Meter per second. So how do you find out which of the following is a possible value in this case? So maybe I ask Ryan, how will you find? Which one is possible? Which is what? What do you do? Okay. Okay, then so the answer is C, correct. So there's a few ways you can do it. So of course, number one, you can do like guess, not say guess and check, but you can sub in all the M and the A together. So you can multiply everything by 2.5 and then you can see which one fits the bill. Or another way, you can find which one will give you that value of A. So you force divide by the mass, then you can find which one fits 2.5 meter per second squared. So the answer is C in this case. Please say no, okay? So 5 divided by 2, that will give you 2.5 meter per second squared. Okay? All right. So that will be all for this question. Okay? All right. So the next question we will go through together is question 4. Okay? But before I go through with all of you, you all read first. Then you see which one you all think is the answer for this one. This is about your Newton's third law of force or motion. Okay, you all think. Okay, which one is a pair of action-reaction force in this case? What do you all think? Then we can discuss together. Okay? All right. Okay, let's discuss together. Okay, maybe, okay, anyway, I'm going to ask everyone here what your opinion of the answer is, because don't be afraid, don't be shy. Just tell me your answer. Okay, start from Kiran. What do you choose as answer? B. Anya? B. B. Raphael? What? B. Okay. Chandran? Okay, Almira? Nasha, right? C. Isaac? Okay, so the answer is, take note, is B in this case, right? Now, but let me go through why is it B and not the other options. Okay, so everyone please take note. The reason why is it B, so B is P and R. So let's go through why. Now, everyone please take note, this is your Earth. Let's say, imagine this is the Earth and this is the Moon, correct? Now, please take note, you must have two bodies. So what are the two bodies? The Earth and the Moon, right? That's the two bodies. Now, the first force is your Earth pull on the Moon, right? So that is the force. Wait, let me read the description here. The force on the moon due to the earth. Correct. So the earth pull the moon. So this one will answer P, right? So that's why they say the force on the moon due to earth. The earth pull the moon forward, right? Now, the other force in this case, it must be from moon to earth in this case. So that's why the force on the earth due to moon, that will be the R that they're referring to here in this case. So remember the action reaction pair, number one must be two different bodies, earth and moon. The second thing is earth act on the moon. The second one is the moon act on the earth. So it must be always be like that, the pairing. Okay, all right. So the other answers are not correct because got sun suddenly, but there's nothing about the sun, right? Yeah, nothing much. Okay, so that's it for the answer. Sorry, it's B. Sorry, wrong. Okay, any questions? Oh, okay, so the next question that I need y'all to try is this one. So can y'all skip all the way to the structured question 12 in this case? Okay, so question 12, also same thing. We have discussed this just now quite extensively. So I want y'all to try by yourself first. Question 12. I will give you about 5 minutes also. Can y'all try? Uh, this one. Wait, let me see. No, it's the resultant force they're talking about. Yeah. Okay. Is everyone okay with the question? Some time to try. Okay, is everyone okay? Left a few more seconds, then we can go through the next part for today's lesson. All right. Okay. So let's go through the questions together. Okay. For this one, please take note. They have provided quite a bit of information here. They told you we have a mass car of 1500 kg, accelerate from rest to 40 meter per second. And then we have some resistive force, which is 4,500 Newton in this case. Okay. So firstly, they want you to calculate what is the force needed to cause this acceleration. So just now, Anaya asked a very good question. Now, please take note, this is obviously, they want the resultant force. Because, right, only when you find resultant force, then you can calculate the acceleration. So, but the problem here is this question, how to find the acceleration? What's the formula we all need to apply? Anaya, any guesses? Correct. So that is the formula you need to apply here. All right, so what's the V? Based on the info. Correct. Why 0? Why minus 0? Because? Very good. So at rest, the speed is equal to 0 meter per second. So you can find that the acceleration is about 8 meter per second squared. Then from there, you can find what is the resultant force, which is MA. So 1,500 times 8 in this case. So you should be able to get around 12,000, I think, right? Is my math correct? 12,000, right? Correct. 12,000. Okay, thank you so much. So the force you need is 12,000 Newton. And take note, this is the resultant force you need. Okay, all right. Now, from there, you need to find the value of the forward F in this case. So, if the resultant force is 12,000 Newton, so let me ask them, Raphael, how to find the forward force then after that? Correct. So, the F minus the friction, right? In this case. So, the friction they have given you is about 4,500. So, 12,000 equal to F minus the friction. What's the friction again? 4,500. So the force you need here will be 16,500 Newton. So that's the answer for this one. Okay. All right. So that's it. We are done with this one. Okay. The most important question is C. This one, please put a big star. Because this is the type of question, the explanation type of question they will often ask. And you need to know how to answer this question. Okay. So everyone, please put a star after you done copy. Yes. You shift 4,500 from negative become positive. Yeah. Yeah. Then become plus, right? So 12,000 plus 4,500. Yeah. Is my math correct? 4,500. Yeah, correct. Yeah. Okay. All right. So that's it. Okay. Now, this one, everyone, please pay attention to this point here. This one usually is about a 2-mark question, and therefore 2 points they are looking for. Now, they say the car continue to remain to journey at constant speed. Now, this keyword, very important. You must address this constant speed. Now, first question, just now I say, constant speed, let me ask Chandran. Means the acceleration is equal to 0. That means, is there a resultant force or not? Then. No. Why? Why no? Do I have? What's the formula for resultant force again? FR equal to M. If the A is 0, means the FR must also be 0. That's the answer. That's the first point we are looking for. So, first point, you all must say, since the car or the driver is traveling at constant speed. Sorry. Yeah. Later I pass you. Hold on, give me a minute. No worries. What I want to say? Lost my train of thought again. Hold on. Acceleration is 0. Sorry. Acceleration is 0. And hence, resultant force is also 0 Newton in this case. So that is the first point that we are looking for wherever you explain this side. But that is not sufficient because after that, you need to explain why the friction, why the resultant force is 0 at the end of the day. Which one? You cannot see. Then you see in front. Come. You want to, okay, can. Okay. All right. So, what I was saying, you see, I lost my train of thought again. Resultant 0, right? Resultant force. Now, then how to explain why resultant force 0, everyone? With that. What happened? True, but that doesn't really address the forces, right? Because they want you to explain based on the reference to the forces acting on the car. So if there's no resultant force, everyone, what does it mean? Come, anyone want to try? Balance, right? What balance? Because what is balance with what? And the correct is balance or technically equal to each other, right? Only when it's equal, then the resultant force is exactly 0. So that is the second point you must say. You must say the forward force is equal to the resistive force. Is equal to the resistive force in this case. Okay, that's all. Those are the 2 points you need to say. Okay, any questions so far? No? Okay, so we are done with the dynamics. So the dynamics, those are the more important one, especially this question. So make sure you all take note, especially for this question, especially part C. How do you answer the question? Like, why is it constant speed? And why resultant force 0? Okay, so we are done with dynamics for the meantime. So we'll move on to turning effect of force. Turning effect of force, right? I will just go through very briefly because to be honest, it's not overly difficult, but I will highlight some of the key important points for turning effect of forces. Anyway, where am I? Oh, sorry, my notes, right? Give me a minute. Okay, so let's take a look at turning effect of forces first for the notes. Where is it? This page. 7, right? Thank you so much. Okay, page 7 in this case. Okay, that is the moment. Okay, so turning effect of forces, right? I'm going to just highlight one thing only because, right, in your syllabus, the most important thing is you all must be able to solve any questions involving principle or moment. That's the more important one, right? And later I will illustrate with using some of the examples in the question. Now, as you all know by now, moment by definition, I mean, in the another name for moment is turning effect of force, but the definition, everyone please take note, it just means the moment is the force equal to the product. What is the English? Hold on a moment. Oh, okay, correct. Equal to the product of the force and the perpendicular distance from the line of action of the force to the pivot. So let me quickly explain. Essentially, it's just a formula. The moment here is equal to force times distance. Now, but the distance, I need you all to be a bit careful, is the perpendicular distance in this case. Okay, so please take note of that. Now, in terms of SI unit, let me explain what are the things you need to take note. Force, as you all know, is Newton. All right, that is the SI unit. Let me ask then, Isaac, what's the SI unit for distance usually? Meter. So the moment usually is Newton meter lah. Correct? That's it. All right. Now, but I want you all to be careful. In exam, sometimes they will not test SI unit. So sometimes they will give you cm. If they ask for cm, then the SI unit, not SI unit, but the unit will become NCM. So please read your question carefully. What unit they want? So there are 2 units, 1 and 2. Just read your question carefully. Okay, they will tell you what they want usually in this case. Okay, so anyway, let me elaborate on this. What does it mean by perpendicular distance, right? So I'm going to draw something here. So let's say, imagine this is a seesaw, right? Okay, this is the seesaw. If let's say I add the force here in this case, F. Okay, F here. Okay, so the question then becomes, what is the distance? Or to be more specific, perpendicular distance from the force to the pivot. So the perpendicular distance will be from here to here. This is the distance. And it's perpendicular distance in this case. So you must always take note, reference from the line of force or the force itself to the pivot. The pivot is here. That will be the distance you will multiply by in this case. Okay. What did we start? 6:30. Oh, time flies. Okay, anyway, yeah. So force times distance. Okay, now let me give you a bit more tricky question. Okay, this one. Let's say again, I give you this and this, right? But this time around, the force is this way. So the question is, where is the perpendicular distance? Vertical. But is it perpendicular to the force? Because the force, the Malay word is saying it a bit slanted, right? So what will we, you cannot say this because you see, it's not perpendicular, right? How, what line down? Or like vertical down or what? Same thing. So if you, let's say you draw like that, right? Is this perpendicular? No. So how? What will be the perpendicular distance? How? Anyone know? Yes. Right angle from where? Force to the. Very good. So you must use like a set square. You have to draw, let's say, a right angle like that. This is the distance actually. Everyone, please take note. Okay. So perpendicular distance from the force to the pivot. Okay. So your exam sometimes they will test you a very simple MCQ question from the force to the pivot. What's the distance? Okay. But usually for your calculation question, usually we will not ask you to do this We will do mostly this scenario in this case. Okay. But you still need to recognize this as per usual. Okay. All right. This case. All right, so that's it for the definition of moment. Now, the most important thing you must take note about this topic is the principle of moment. And this one, please take note, please memorize, because why? This one usually is a 2-mark question. They will ask you, what is the principle of moment? Now, there are 2 points usually we are looking for. What is the first point? The first point, you all must say, when the body is at equilibrium. That is the first point you all must say. That will give you the 1 mark. Okay, when body at equilibrium. Later I will elaborate what's equilibrium. Then the second point, what's the second mark? The second mark, you must say, the sum of the clockwise moment about any pivot is equal to the sum of anti-clockwise moment about the same pivot. This one will be the second mark we are looking for. I know a bit disproportionate because in terms of the length of the answer, but those are the points they are looking for all the time when you are defining principle of moment. Okay, all right. Okay, but first question I want to ask, Destiny, can I ask you, what does the word equilibrium means? Any guesses? Sorry, equal, is it? I heard equal. Equal in what way? Come. Or Chandra, you want to help her also, can? Any idea? Very good. That's the answer I'm looking for, right? Now, the word equilibrium, please know, in your O level, right? Some words that they might use in exchange of equilibrium. Aaron, please know, it means number 1, horizontal. Number 2, perfectly balanced. All right. And number 3, of course, equilibrium. So all these words, they were used to indicate that the ruler or whatever object is no longer moving, right? Or turning in this case. So it's at equilibrium. Okay, so that is the idea of equilibrium. Now, so today, right, we're going to talk about how do you go about principle, the calculation involving principle of moment. Now, wherever you have any questions involving principle of moment, depending on your school might want you to say this word. Your school got say this, the taking moment about a certain pivot, then you must say sum of anti-clockwise equal to the sum of clockwise moment in this case. So some school, they need you to write this keyword in order to gain the full marks in this case. So if your school needs to, please go and write down. For O level, I will just advise write also. Just take note. Okay? So just write in case they do ask. Okay, all right. Okay, so anyway, I'm going to use the empty space here at the next page. So let's discuss some important things you need to take note about moment. Okay, so let's have this scenario. Okay, come. Sorry, let me just draw 50 cm here. Okay, you all can copy down first. Later we discuss about this. Okay, everyone ready for the principal moment? Okay, let's discuss what is the idea of principal moment, right? So let's say I told you, number one, this ruler that is holding some weights, okay, is balanced, right? Or at equilibrium in this case. Now, important keywords you all must take note wherever you do any questions involving principal moment, is the word uniform. Okay, so everyone, please put a star, uniform. Now, let me ask first question. Kiran, what does it mean by a uniform meter rule or a uniform object usually? Straight. Not really. Uh-huh. That's in the math context. But let's say if you're talking about an object, let's say I told you my laptop is uniform. What does it mean by a uniform object or a uniform iPad? Anyone? Okay, but anyway, good try. Anyone got other answers? I try. Length of the ruler is the same. What do you mean by that? True lah. But let's say if I give you a 1 meter ruler and I told you, oh, this meter ruler is uniform. What does that mean? It's not really the length. It's something else. Anyone know? Anyone? Follow up? Okay, wait. Those at home. Yes, Ryan. No, it's not negligible. Yeah. Uniform means not negligible. Please be unless I say negligible mass, then I will say, yeah. Okay, Renzo? Huh? No, it's not equilibrium. So there, uniform means the center of the gravity is at the center of the object in this case. Please take note. So center of gravity, which essentially is the weight, i.e., is at the center of the object. Okay. So take note, if it's 1 meter ruler, sorry, my student disturbing me. Okay, 1 meter ruler means where's the center of gravity, everyone? Is at where? Around where? What length? Middle? What's the middle length? 50 cm. Everyone take note, the center of gravity is around here. So this is the weight of the ruler. It's at the 50 cm mark in this case. Okay, and later I will highlight why is it important to know about this, because they will ask you a follow-up question later on. Okay, but anyway, let's for the meantime, KIV this. Okay. All right. So anyway, let's say your aim or your job here is to find the weight, right? So let's say I told you the weight here is 100 Newton. Then find for me the weight W2 that causes this object to become balanced. Okay. So the principle of moment is what you need to invoke. So you need to say by principle of moment about the pivot. Then you must say sum of clockwise moment equal to the sum of the anti-clockwise moment in this case. Okay, you have to say this very clearly. Okay, Chandra, okay? Can see? Can see, Okay, now let's discuss who are the clockwise, who are the anti-clockwise moment, right? Okay, so every time when I do any moment question is this, look at all the forces that are in the diagram. So here, the two forces that are acting on the, in this case, the ruler is W1 and W2, correct? Because it's pulling downwards. Now, every time I do any moment question, I will draw from the action or the force, I draw all the way to the pivot in this case. That is what I will always do. From the force, draw to the pivot. Then you all will tell me, is this a clockwise or anti-clockwise moment in this case? So let me ask Elmira, what is the moment? Is it clockwise or anti-clockwise? This one. This one is anti-clockwise. Then what about from here to here? Is obviously your clockwise, right? So that is the idea, the first thing you all must do. Then from there, you need to apply your moment formula, which is force times distance. Okay, so let me ask Elmira. Let's talk about the anti-clockwise first. What will be the math, the moment? Times 10, correct? So it will be 100 times 10, right? Then what about the what's that? Clockwise moment? Then what will be the math? Times 30 lah, correct? In this case, right? Everyone agree with the math? Make sense? All right. Then after that, you just solve it as if you all learn algebra, right? So the W2 here will be 1000 divided by 30 is 33.3 newtons in this case, around there. Nope, cannot. Physics cannot. Chemistry also same, yeah? Cannot, give in fractions. So that's the answer, 33.3. 3SF or depend your school, some schools say 2SF. So you all can just check with your school. Okay, whether you want 3SF or 2SF in this case. Okay, all right, so that's it lah. Okay, the next follow-up question, I got a few follow-up questions. This one very important. Number one, just now Elmira say, right, the moment, right, is 100 times 10, correct? And then this one W2 times 30, right? But the unit I give here is CM. Now, can I leave my answer in, what's up? When I do the multiplication, can I leave in CM technically? Can or cannot, everyone? Isaac say can. Isaac say can. Is it? Why? Why can? Not sure. Why? Anay, where is it? Can? Correct. Or essentially, right, as long your unit is consistent on both sides. If you use CM here, then you must use CM here. You don't suddenly 1 cm, 1 meter. It doesn't work this way. So if you want to keep both sides CM, you keep it both sides CM. If you want to change it to meter, then change both sides to meter in this case. When you apply principle of moment, please say, there's no need for you to convert to meter. Not necessary in this case. Okay? So please go and take note of that. Just be consistent with your units. Be consistent with units. Okay? All right. That's the first question I will ask. Like, why shouldn't convert lah? Up to you lah, whether you want to make your life difficult or not, right? Okay, now the next thing we're going to discuss is about the uniform meter rule part again. So as what I mentioned, uniform means the center of gravity is somewhere in the middle, 50 cm, right? Now, if you realize, I put the pivot also at 50. Now, can I ask all of you, why do we not care about the action of the weight here in this case? Why do we not calculate the moment that is caused by the weight of the ruler? Okay, come. Anyone want to try? Very good. Why no perpendicular distance? Because it's exactly at the pivot, right? In this case, unless I shift the pivot somewhere, then you must care about it, right? But here, everyone take note, the pivot is exactly on the weight. So this is the next question they like to ask is, why we don't take moment of the weight? Okay, and the answer to the question will be because the weight lies directly above the pivot. So hence, no perpendicular distance. That's all. Okay. And therefore, the moment is also 0. We don't care about it. Let me zoom for Chandra in case he cannot see. Sorry. Okay. 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 Any questions? Anyone? Okay. And then we will practice some questions. Okay, but I will go through one question together with all of you first. See whether you are comfortable with it. Sorry, this thing is not being weird. Okay, everyone okay? Okay, so now everyone, let's turn to your the questions. Hold on, let me see. Hold on. Yeah, correct. So can you all turn to this question? Hold on. Skip the pure one. Let's take a look at question 10. Okay, MCQ question 10, everyone. It should look like this one. This one. This diagram. The toy diagram. Okay, all right. So I'm going to use this example to illustrate what we just now went through. So this example we'll go through together, but later the next question, which is a structured question, I will give you all some time to try. Okay, anyway, you all read first. Give you about 30 seconds. Read the storyline first. Okay, ready? Okay, so let's do this. Now, what are the key points or the keywords that you must take away from this question? Take note, equilibrium. Okay, so once you see the word equilibrium, means what principle do we need to invoke, Elmira? Equal to? Correct. So that is your principle of moment. So wherever you see this word, you must invoke your principle of moment question. As what Elmira say perfectly, sum of clockwise equal to sum of anti-clockwise moment in this case. Okay. Now let's take a look at this diagram. So let me ask Ryan, what are the forces acting on this? What is this thing? This rock. By who? If you look at the diagram, it is or tension force, but they never talk about tension here. So you must read based on the context of the question. So firstly, what information they provide to you is, number one, they have given you the weight of the plane. Okay, everyone take note. So the weight of the plane is pulling the rod down, and also the weight of the car. Okay, so that is the information given to you. Now, next thing, every time you look at this kind of question, you must identify the pivot carefully. So, Regina, where's the pivot in this diagram? At the thread, at the Y lah, right? In this case. So this is the pivot. Always identify the pivot carefully. Because later when we decide on the clockwise and the anti-clockwise, you must always point to the pivot. Okay, so let's do this. From the weight of the plane, we point to the pivot. Period. Is this clockwise or anti-clockwise? Anti-clockwise. Then from the the toy car to the pivot, it will be clockwise in this case, right? So then we invoke the principle of moment. The sum of the clockwise moment equal to the sum of the anti-clockwise moment in this case, right? Okay, so come, Kiran, you help me with this one. What's the math it will be for the clockwise moment? Okay, that will be the anti-clockwise. So 1.8 times 20, and then the clockwise. Which is what? Correct. Which is what you want to find. Yeah, correct. Then after that, what will be the math? YZ will be 1.8 times 20 divided by 1.5. Correct. So the value of the YZ you will get will be 24 cm in this case. Okay, so the answer will be C. Okay, so this one are very simple because why? There's only two forces acting, one clockwise or anti-clockwise, right? When you see such, much more difficult question is when you have multiple forces acting on it. So you all have to just make sure, be careful about that. Okay, all right. So which is the next example that you are going to try by yourself. So can you all take a look at question 40 now, in this case? Where's 40 now? This one. Okay, come. This one. Okay, so this one, I will give you all about 5 minutes. Can you all try this question by yourself first? Okay, question 5. 40, sorry. Okay. questions? Anyone? Yeah. Some time to try. Then we can discuss. Okay. So wait, hold on. Give me a few seconds. Okay. So let's go through this question together. Then later you all will try one more, then we will take a break, okay, for a while. Okay, before we move on to chemistry. Okay, firstly, everyone please know, what are the key important information that was given to you in this question? Number one, they say uniform. Please take note. So uniform means what? The center of gravity or the weight of the what's called meter rule is exactly halfway mark. So the weight is somewhere here in this case. Everyone please, oops, sorry. Let me use a different color. Weight somewhere here, exactly above the pivot, because the pivot is exactly at the 50 cm mark. Now, please take note, they say then we have 0.05 kilogram of the mass and a cube of our unknown mass. We do not know. So we have certain weight here. We do not know. And then they told you that the meter rule is horizontal and remain at equilibrium. So again, this word important because right, that means you can invoke your principle of moment. So anyway, part A, we already addressed the answer to the question why we don't care about the weight, which just now Anaya told me the answer. Number one is because there is perpendicular distance from the weight to the pivot is exactly 0. From the weight to the pivot is 0. Okay, that's the first point you all want to say. Then the second line, then you just tell me, hence, it does not produce the moment, or the moment is 0 in this case. Yeah. Doesn't matter. 0 is 0 lah. Yeah, in terms of unit also same. Okay, so think of, okay. All right, so that's it for A in this case. All right, now the next one we're going to discuss is the calculating the moment. Now, this one, I need you all to be a bit careful because right, this question, they didn't tell you the unit. Usually for your exam, right, they will write the unit somewhere here. So if they write for you the unit, you all will know what unit they want. But if they never write the unit, please take note, is by default must be SI unit. Everyone please take note. So check whether you have given the SI unit of moment to be Newton meter. Your check. Okay. Anyway, let me go through the moment. Yes. Probably cannot because usually by default must be SI unit unless stated otherwise. Yeah. Okay. So let's talk about the moment. But before we talk about moment, everyone please be careful. They told you in this question here, the mass that they have given you for this one is 0.05, right? This is mass. Please say no, mass. Is this force or not? F. Everyone. The answer is no. So the first thing you are supposed to do here for this question is, okay, let me shift it down. You are supposed to find the weight of the object first. Now, for those who forgot to times by the G, you will get it wrong because you forgot to times by G. So the mass is 0.005. Depend on your school. Some school will encourage to write the formula. Okay, so you will get 0.5 Newton. Okay. So a lot of you might have forgotten to convert from mass to weight first. Please go and check your calculation. Okay. Then from there, you go and calculate the moment, which is force times distance. So the force is 0.5, of course, right? That's what we calculated. Now, the next question, let me ask Regina, what is the distance in this case from the mass to the pivot? What do you say? 10 cm from here to the pivot. Be careful. It's always point to the pivot. All right, it must be 40 cm. But can I give 40 cm? Leave it at 40 cm? No, so must convert to meter, which is, what's the conversion? Not really. 1 meter is 100 cm, right? So then from cm to meter will be divided by 100. Okay, so be careful. So from 40 cm to meter must divide by 100. So the moment will be 0.2 Newton meter. That's the answer. Okay. Correct. The math is correct. 0.2 Newton meter. Yeah. Okay. So then they say state the direction of the rotation. All right. So come, Chandra, what is the rotation? Clockwise or anti-clockwise? From the mass to the pivot. Anti-clockwise, correct. So you must say anti-clockwise in this case. Okay. All right. Ken, any questions? Okay, that's it for the first one. Now, the next problem here, then they say, hence, calculate the mass of the cube in this case, right? Okay, so we already settled the anti-clockwise. We know that the anti-clockwise is 0.2, settled already, right? Now, the problem here is we need to figure out what is the clockwise moment, which is, of course, is caused by this cube, correct? So this cube, if you point to the pivot, this is clockwise. Wait, sorry, let me write anti-clockwise and clockwise in this case, right? Everyone agree? Clockwise. Now, the next question then, Destiny, can I ask you, what is the distance from the weight of the cube to the pivot? Try again, 25. But can I leave in 25 cm here? Cannot. So must divide by 100 also, right? So the W weight 2 times 25 over 100 in this case. Okay? So if you do the math, the weight will be 0.8 Newton in this case. Okay? Now, here, let me clarify one thing. If you have left the answer in cm here, and if you are consistent here at cm, we will still give you the marks. Because remember, in physics, there's ECF mark, right? Because the distance is 25 cm. Then must convert to meter. Because we make it meter here, right? Then you must be consistent in your unit here also. Must be meter. No, not the answer yet, because this is the weight, right? Now, because they ask for mass. So what's the formula again? You must apply W equal to mg law again. Correct. Yep, correct. So mass is then G. So mass is 0.08 kg in this case. This one, if you want to live in kg, can. If you want to convert to gram, also can. Because why? We never tell what's the unit they want, right? If they specify the unit, then please go and do the necessary conversion. Okay, 800. Sorry, 1, 2, 3, 80 gram. Kg. Yeah, you can leave it up. But unless they ask for gram, then you leave it. You convert to gram in this case. Okay, so that's it for this one. Any questions? Okay, maybe we'll pause here for the meantime. So please go and have a good 5 minutes break. If you didn't know, the toilet is a bit far. You go out, you turn all the way right, walk all the way down to the pantry. There's a toilet. The guys' toilet, very obvious. The girls, the ladies must go through another door. Okay, if you let's say you want to go toilet. Okay, so please take a good 5 minutes break, everyone. Please enjoy. Okay, I also need to use the toilet. Okay, I can show where are the toilet if anyone what's going toilet. Okay, we wait for a while for the rest to come back. Then we will start. Okay, who's missing? Anyone else? Okay. Can. Why is full inside? Can. But I don't know whether got people that's the thing. Because there's only one toilet cubicle there. Yeah, you can go first. Yeah. Why this song keep repeating on? Okay, so hold on. Let me see. I'm going to be done where let me talk about this. Yeah, my headache. Hold on, give me a minute. Let me see the notes first. Okay, okay, we will start first. Okay, we're waiting for who? Destiny. Wait, no Destiny. Sorry, Regina. Okay, okay, I'm done with the physics for the meantime. Okay, so for the physics, right? Please take note. Later I will give you all the answers to the question. Please go and try to practice the main important points in the topic. So I already highlighted what are the main points you all need to know or focus on when you're doing any of the what's called question involving dynamics and also turning effect of forces in this case. Okay, so anyway, now we're going to go through is the chemistry portion. Let me close the song. Sorry, again. Sorry, anyone? No, wait, left. Who is? She just went toilet, right? Yeah. Okay, so let's go through chemistry for today. Okay, so the two topics I'm supposed to go through are mole concept and acid base, right? Yeah, I think so. I'm supposed to go through this too. Okay. All right. So let's start with mole concept first for today. Okay, in terms of revision. So y'all can flip to your chemistry notes first. Let's take a look at the mole concept in this case. Come. Okay, everyone have the notes? Okay, so for the first part I want to discuss with all of you is the definition. Now this one, again, I just let you know, for chemistry, if you want to memorize the definition, go ahead. If you don't want, it's fine. It's 1 mark only. Right? But for physics, usually we will advise you all to memorize the definition because they often test definition question. But for chemistry, my advice, if you want to let it go, let it go. Okay? Try to do other questions, much more important questions in this case. Okay, but anyway, let me revise with all of you what is AR and MR. Now, AR by definition is what we call relative atomic mass. Everyone, please say note. Relative atomic mass is the definition is average mass of an atom of an element when you compare to 1/12 of the mass of a carbon-12 atom in this case. Now, please do not ask me why they decided to use the carbon-12 atom as the reference mass. This one, it was decided by a community of scientists in this case, okay? But that is the reference. The reference is always carbon-12 in this case, okay? So we will take the value, we just divide by the mass of carbon-12. Now, but the thing is that in general, right, how do you obtain the AR value in this case of an element? So if I ask you, what is the AR of sulfur? Where do you find this number, everyone? From your periodic table, right? Now, but here, my warning to all of you is this, which number in your periodic table? The top number or the bottom number, everyone? In your periodic table. Wait, where's my periodic table? My periodic table missing. Okay, come. Which number? Sorry, messy. But anyway, what number? Top or bottom number, everyone? Bottom. Please read the legend carefully. They literally telling you who is the number here. Relative atomic mass is the bottom number in this case. So you should take the bottom number. So for sulfur, the relative atomic mass should be 32 in this case. Okay, so please go and pick up the correct number. That is relative atomic mass. Okay, now there's a second definition, which is MR. But unfortunately for all of you, MR got two different definitions. But because why? Later I will discuss with you. One is relative molecular mass. The other one is relative formula mass. Now, what's the difference? One is for, take note, molecules. The other one is for ionic compound in this case. Okay, so that's the difference. One's for molecule, one is for ionic compound. Now, when I say someone is a molecule, I want to ask all of you, what kind of substance is this? If I'm referring to molecules. Let's say, I give you an example, CO2. What do I mean by that? Covalent, very good. Means they are covalent substances. Okay, so you can see relative formula mass is meant for ionic, but relative molecular mass is meant for covalent. That's the difference. That's why they have two different definitions for two different substances. Now, but at the end of the day, the thing is, MR, we can represent MR either this or this. And if I ask you to calculate the MR of, let's say, CO2, how do you all go about calculating the MR of CO2? In this case, let's say I ask for MR or CO2. How do you all calculate? What would be the math, everyone? You all know how to calculate? Any idea? Ryan, do you know how to calculate MR or CO2? Some more? Continue. 44. How do you get 44? So all, as what Ryan trying to say, right? Carbon is 12, right? Then oxygen is 16. But take note, there are two of them. So 12 plus 2 is 16, which is 44 in this case, right? So MR is just the sum of the individual AR at the end of the day. Okay, so that is the idea. So it's the sum of the AR. Okay, so you just need to add up. Oh, sorry. Okay, so that's it. All right. Anyway, I will leave it to you. Whether you want to memorize the definition. Okay, and then molar mass. For those who have never heard about molar mass is a fancier word of saying relative molecular mass or relative atomic mass. It's just that molar mass got unit only. That's all. The rest of them got no units. Okay, so if your school got mentioned about molar mass, which usually they don't test for O level for combined science, you just need to take note, okay? Molar mass got unit, but the others no units. Okay, but the numbers remain the same at the end of the day. Okay, all right, so that's it for this particular formula. Okay, now let's talk about the most important formulas for this topic. So first, second, third, fourth, fifth. So these are the 5 formulas you all need to know for mole all the time. Now, wherever I talk about mole, this is what I'm talking about, the 5 formulas. Oh, sorry. Thank you, Jimmy. Thank you. Okay, so let's go through the first formula. Now, the first formula that you all need to know is you must have the idea of what is an Avogadro's constant. Avogadro's constant, as you all know, this number is 6.02 times 10 to the power of 23. Do you need to memorize this number, everyone? Yes, or actually it's found in your periodic table at the bottom. Okay, my periodic table no have. Are you here? Okay, is here? This thing is at the bottom. Okay, this one maybe don't have, but your official exam one, they will have the number at the bottom here. Okay, so please go and take note of the number. So the number is 6.02 times 10 to the power 23, right? Now, here is where a lot of students always have a problem. They do not understand what does Avogadro constant mean. Now, usually this is what I will tell students. Avogadro's constant, it just means how we package things in this case. Now, I will give you an example. Let's say if I ask you, buy a dozen of egg. What is a dozen of egg, everyone? 12, right? Instead of telling you buy 12 eggs, I say buy a dozen of egg. So the dozen is a repackaging of 12 eggs in this case, right? So the Avogadro's number is the same because, right, the problem here, let's say if I give you this microphone, right? Obviously, you all know everything in this earth, metal essentially is made of atoms, right? But atoms are very, very, very small. Then how are you going to quantify the number, right? That is difficult. So that's why instead of dealing with very, very small atoms and then the number being very huge, might as well I make my life easier. I package them. 6.02 times 10 to the power 23 is equal to 1 mole in this case. That's how we package things up. Okay, so that is the idea of mole. Okay, for those who don't understand what is mole, okay, so that is the first thing you must understand. 1 mole of anything is 6.02 times 10 to the power of 23. Okay, and what is that now? What is that thing? It's called particles in this case. All right, now, but here, let me clarify one thing. Particles can refer to a lot of things. Let me explain. Particles can refer to atoms or molecules or ions. right? Your syllabus usually will cover atoms to molecule. Ion very rare, but you can just take note of that in this case, okay? Now, let me give you all an example. So I'm going to use this space at the bottom to kind of give you an idea. So let me give you a drawing here. Let's say I have 4 water molecules inside. Okay, water look like this. This is water. 4 H2O molecules in this case. Okay, the big one is O, and the small one are H's. Okay, you all can get my point. Okay, so 4 water and molecules in this case. Okay, so I'm going to give you this example. Then later you will try the next few examples by yourself. Now, let me ask a very important question. If you look at my diagram, yeah, I got 4 water molecules, right? But what if, let's say, instead, I ask for the number of hydrogen atoms inside this diagram or this drawing? So maybe guys, Regina, if you count, right, how many hydrogen atoms I have here? 8, correct? Everyone agree? 8, physically count 8. Then, next question, Anaya, how many oxygen atoms are there in my diagram here? 4, correct? Because you can just count 4. Now, but you realize there's a pattern here. So, Regina told me got 8 water. Anaya told me got 8 water, sorry, 8 hydrogen. Then Anaya told me got 4 oxygen, right? Then you realize, these numbers, right, looks very familiar because, right, the ratio of hydrogen to oxygen is 2:1, which fits the formula of water. Water, the formula is H2O, right? So that is the idea of the of this whole topic. This topic, the most important thing is what we call mole ratio. It's just the ratio of the atoms in this case. Okay, so I'm going to give you another example. Then you'll try what's happening here. Okay, all right, everyone ready? Now I'm going to use mole. Let's say I told you I have 0.25 moles of what molecule can I think of? Okay, what molecule I cannot SO3. Okay, let's go SO3 molecule. Okay, sulfur trioxide. Okay, and this is a molecule. Okay, 0.25 moles of SO3 molecule. Now, the first question I want to ask is this: how many SO3 molecules do I have in 0.25 moles? Anyone want to try? Come. Anyone want to try? Math. What's the math? Anyone? Okay, come, Renzo. What is the number of molecules of SO3 we have in 0.25 moles? How many SO3 molecules will I have in 0.25 mole? No, I want SO3 molecule in 0.25 moles. Times? Correct. 0.25 times your Avogadro's constant. Remember, as I mentioned, 1 mole of any substance is always 6.02 times 10 to the power of 23. So if I have 0.25 moles of it, you just need to multiply by the Avogadro's constant. That will give you 0.25 times 10 times 6.02 times 10 power 23. So if you press your calculator, you all can get the value. I don't want to evaluate here because I don't want to confuse all of you. I want you all to see the math with me. Okay, so the first thing you all observe, in 1 SO3 mole, 0.25 mole, got this number of molecules in this case. Okay, now let's say now I want to find out how many now oxygen atoms I have in 0.25 mole of the SO3. Okay, first question. What's the ratio between SO3 to O in this case? Let me ask Destiny. What's the ratio between SO3 to oxygen? Sorry? 1:3. Very good. Right. So everyone take note, there is for every 1 SO3, got 3 oxygen, right, in the formula. That means, everyone, if I have 0.25 mole of SO3, so Destiny, what will be the math? How many moles of oxygen do you have? 0.75. Very good. So 75 mole. And then from there, 0.75 times the Avogadro's constant. Okay? Who don't understand what I just said? All these is ratio. It's a ratio problem, right? Now, common mistake student will tell me is this. They will tell me, oh, 0.25 in SO3, right? Then they will tell me, oh, divide by 4. Because why? In the formula got 4 atoms. Then they tell me divide by 4. It doesn't work this way. In ratio, mole is always about ratio. So as what just now Destiny told me, 1 SO3 got 3 oxygen in this case. Then the math will work as per normal, mole ratio. Okay, mole ratio like what you all do since primary school. 1:3. If this 0.25, this is 0.75. And then okay, can? Okay, next question is this. What is the number of sulfur atom that in this case? How many sulfur atoms do I have? Okay, come, Anaya. Can I ask you, in one SO3, how many sulfur atoms do you have also? Also 1, right? So 1:1. So means how many more? I mean, if let's say SO3 is 0.25 more, then this one will also be correct because it's 1:1, right? Then the math will be 0.25 times Avogadro's constant also. Okay. Last question. Then, what is the total number of atoms then? Everyone. What's the total number of atoms? Because why? So because, right, if you see on my ratio, right, total here, if you add up, is 1 mole. Correct? 0.75 plus 0.25 is 1 mole, right? Then after that, you times by Avogadro's constant is 1 times 10. It's 1 times 0.62 times 10 to the power of 23. That's all. Okay, so these are the type of question you must be careful. Read the question carefully. Do they want molecule or atoms? And if they are talking about atom, which atom? Is it the total atom or the individual atom? So you all have to deal with the ratios carefully in this case. Yeah. Which one? Oh, the total mole, is it? Yeah. So because, right, take note, they say how many total atoms, right? So we already found out that oxygen, the mole is 0.75. Then the sulfur is 0.25, right? So if you add up all the atoms together, it will just be 1 mole at the end of the day. Then of course, then you multiply by the Avogadro's constant, mole times Avogadro's constant. That's why it's 1 times 6.02 times 7.3. Okay? Okay, everyone okay? Okay, ready? I will give another example. And this is the example I always like to give students. Okay, everyone okay? Ready? Oh, sorry. Okay. Okay, everyone ready? Okay, you all have space, right? Do you have no space? If no space, you all can use the empty space somewhere on the next page also lah. If you got space, okay? Okay, so I will write here. This one, everyone please say what? I have 0.5 mole of glucose, which is C6H12O6 molecule. Okay, so there are 5 questions to this. Number 1, how many glucose molecule I have? Number 2, how many C atoms? Number 3, how many H atoms? Number 4, how many oxygen atoms? Number 5, total number of atoms. Okay, just go and do the calculation. So figure out the math. Find for me how many molecules and how many atoms. Okay, let me top up my drink first. Okay, everyone done the math? Everyone okay? Math? Okay, math. Okay, okay, so let's go to, sorry. Yeah, 12, correct. Yeah, so C6H12O6, glucose. Okay, so let's go through the math first. Okay, so one by one, I will go through the first one, which here, everyone please say, they have 0.5 mole of glucose molecule. So they want you to find how many glucose molecules do you have. Okay, starting from Raphael, what's the math for this one to find glucose molecule? Correct. So the Avogadro's constant, I will leave my answer like that. Because of course in exam, please go and evaluate, but I will leave it like that. So for clarity purposes. Now, the next one, Chandran, can I ask you then how to find the number of carbon atom first? So firstly, what's the ratio between glucose and carbon? Very good. So if you have 0.5 moles of the glucose, that means how many moles of carbon do you have? 3. Very good. So it's 3 moles in this case. Then the math will just be 3 times the Avogadro's constant in this case. Correct? Make sense? Yes. Ratio, because the ratio is 1:6. Because every glucose got what? 6 carbon. So if it's 0.5, then you times 6. 3. Huh? 0.5 moles. What do you mean in total? Like everything must add up to 0.5? No, that's why just now I say the mistake that student make is they will tell me 0.5 divided by 24. Wrong in this case. Yeah, it doesn't make sense, right? So take note, it followed by math one, the ratio in this case. Okay, next one, come. What's it called? Anaya, can I ask you, hydrogen, what's the ratio? Is to 12. So how many mole is that? 6. So means the math will be 6 times Avogadro's constant in this case. Right, thank you. Next one, Regina, what about oxygen? Correct, because ratio is 6, right? So 3, so then the math will also be 3 times 6.02 times 10 power 23. Last one, Kiran, what's the total number of hydrogen atom? Total number of atoms, sorry, not hydrogen atom. Total number of atom, everything. 12, because right? Correct. 3 plus 6 plus 3, total will be 12 moles. So it will be 12 times the Avogadro's constant in this case. That's it. That's the understanding of Avogadro's constant. Okay, so I will repeat, make sure you read your question carefully. Are they referring to atoms or molecules? Okay, then you must do the mole ratio carefully in this case. All right, any questions? Question? All okay, can Okay, so that's it for this one. Okay, you see I spent so much time on Avogadro's constant, so you are expected to know how to interpret. Okay, anyway, the first formula is what we have discussed just now. To find the number of particles is just mole times Avogadro's constant, full stop. Okay, now the second formula that I want to go through, sorry, let me flip back to the previous page, is this one. Most of you should be able to do this question. This formula, which is mole equal to mass over AR or MR. Now, please be careful. To find mole for using mass, the unit for mass must be gram. Please be careful. If it's in kilogram, please do the necessary conversion. So 1 kilogram, as you all know by now, is 1,000 gram in this case. Okay, please go and do the necessary conversion. Then the AR or MR, you should be able to pick up from your, what's it called? Your periodic table in this case. Okay, that's the second formula. Now, the third formula, this one, I want you all to be careful about this formula. This one is for only for gases. Please put a star. And that is, I think the formula is missing. I do not know why the teacher didn't write. Okay, can everyone include volume of gas equal to mole times 24 dm cube in this case. That's the formula. Volume of gas equals to mole times 24. All right, I repeat, this is volume of gas. Now, this one, I have neck at my Sec 4 every time I say, please, when you read your question, the volume they give you, is it for gases or not? Because why? Let me ask all of you. If I give you the volume of sulfuric acid, 200 cm cube, can I use this formula? The answer is no. Sulfuric acid is not in a gas in the first place. So please don't whack the formula anyhow. Look carefully. Is it a gas or not? If it's a gas, then you can apply this formula. If it's not a gas, please never ever use this formula in this case. Okay, make sure you all are careful about that. Okay, anyway, let me ask then. Isaac, what is 1 dm cube equal to? How many cm cube? No, the other way. Correct. So everyone take note, 1 dm cube is 1,000 cm cube. So if you want to convert from cm to dm, then you divide by 1,000. Okay, so please be careful of your unit conversion also. Okay, so volume of gas is mole times 24 dm cube. Okay, the next two are involving concentration. Now, before I start, let me ask Destiny. Can I ask you, what is your understanding of concentration? What is concentration? What? Sorry? No idea? Chandran? You want to help? Okay, Alvia, do you have any idea what is concentration means? And the? Okay, the solvent is the, let's say the water, right? Then what is the thing that we, correct, very good, is the solute, right? So remember, as what you all experience on a daily basis, if you drink bubble tea, if I choose 100% versus 0% sugar means what? 100% means more? What do we call this? More concentrated in this case, right? Means you have dissolved more sugar into the water. If it's 10%, then of course, less of the sugar has been dissolved, right? So the logic is that concentration is just means how much solute have dissolved in the solvent. How much solute dissolved in the solvent in this case, right? That's the idea of concentration. But here, my warning to all of you, your O level, there are two different units for concentration. Is either molar means mole per dm cube, or mass, which is gram per dm cube in this case. They have two different units, okay? One mass, which is gram, one is mole, which is mole per dm cube. So read the question carefully, what unit they want. Usually for O level, we always use mole per dm cube, and this is what usually we give you, mole per dm cube, okay? Now, please say no, what does mole per dm cube means? Per dm cube means what? It means it's a division. So you divide by the volume, divide by the volume in this case. All right, so mole over volume or mass over volume in this case. Okay, that's the formula for concentration. Okay, any questions so far? Anyone? Okay, so anyway, the rest of the formula, you all know, it's not part of the combined science syllabus. Okay, all right, so that's it for the 5 formulas. Any questions? No? Okay, so there is one question that I want you all to try. Can you all take a look at the chemistry combined chem questions? I have no idea what page, but it's this one lah. Okay, can everyone find this one? It should be the last few pages lah. You all can flip. Should look like something like this. Okay, any questions? All right, so the question that I want you to try is question number 1. I will give you about 2 minutes. Can you all try this question 1? Just 1 only for the meantime. Okay, 2 minutes. Okay, then we can discuss this question. Okay, you need to apply your formula. Then later we discuss what formula you need to apply here for this one. Okay, a few more seconds, then we can go through. Okay, all right, let's go through this question together. We will discuss what formula do you need to apply here. Okay, they say I want to find out which gas occupies a volume of 72 dm cube at room temperature. Now here, they have only provided one information only, and that is the masses of each one of the what's called the gases here in this case, right? Now, first question I want to ask, if I'm given mass, right, in gram, next question, let me ask then, period. What formula should you be applying here in this case? If they give you mass. What's the third one? Sorry, what's the formula? Total volume? Volume or gas? Okay, so what you want to do with the volume or gas? 24 dm cube, is it? Okay, then that means 72 dm cube is? Okay, very good. Okay, so I will go through the two different ways. So Kieran, give me one way. Let me go through the one that I think most of you will do in this case, right? And that is you apply that formula. What formula that I'm talking about here by right is mole equal to mass over MR, right? Or AR. I think most of you did that. Is it? You all did that? Oh no, not really. No, it's different subject. Okay, never mind. Okay, but I will discuss with you what are the different ways to do this. Now, the first thing I can do is I can find mole first, which is mass over ARMR, which is the second formula from that table in this case. Now, the first thing, of course, you need to find what is AR or MR first, right? For each one of them. So if you check your, periodic table, argon is 40, right? Argon 40? Yeah, argon is 40. Methane is 12 plus 4 times 6 equal to 16. This one is 3 times 12 plus 8, which is 44. And SO3 is 32 plus 3 times 16, which is, wait, let me think, 32, 64. Okay, that is the MR of each one of them. All right. After you find the MR of each one of them, then you can find or apply the mole formula, right? So you just take the mass, which is what they have given to you, divide by the AR or MR we have calculated here. So if you calculate, this is about, the first one is what? 1.5 mole. This one is 3 moles. This is, this one, sorry, I didn't calculate for this one. Yeah, let me check. 72 divided by 44. Wait. Oh, okay. I think it looks correct. 1.64 moles. And this one is about 120 divided by 64, which is 1.875 mole in this case. Okay, so you take the number here, divide by the MR. These are their respective moles in this case. Okay, everyone agree? The formula. Okay, then after that, what happened? Can I ask all of you? Because this is a gas, right? What formula we can apply is what Kieran said, which is correct, times 24. So the second formula you need to apply here is volume of gas equal to mole times 24. Sorry, Chandran, it's going to get smaller. Okay, my handwriting. Okay, so everything else times 24. The only one that makes sense that it will equal to 72 is B, correct. If you times 24 here, this is 72 dm cube. The rest of them, if you times by 24, you'll get this one divided by 2, which is 36. Okay, then this one times 24 times 24. Okay, wait, let me press my calculator. So 24, this is 45. This one 1.64 times 24, which is 39.4. Okay, so the only one that makes sense is B. Okay, now of course, if you want, you can work backward. Meaning, as what just now Kieran was trying to say, right? If you use 72 dm cube, you use the volume formula, you will get 3 moles, actually. Then, which one is 3 moles? is B lor. That's the answer, right? So you can work backward. 72 divided by 24, you get 3 moles. And therefore, the only one that 3 moles is B. Okay, but that is provided you calculated the MR carefully lah. Okay, that's something you all must be careful about. Okay, any questions? Anyone? Question? Okay, questions? Everyone okay? Sorry, about 40 minutes left. Please bear with me. Okay, so that's it for this portion here. Okay, so this one is the type of question you will encounter lah. Okay, now the next thing we're going to discuss is my favorite part, usually is your stoichiometry problem in this case. Everyone ready? I'm not sure whether you all are okay with stoichiometry. Everyone okay? You all know what stoichiometry, right? It's the mole ratio thing to find how much product you form. Okay, I don't know whether you all remember. Okay, so let's do this. Okay, everyone okay? Copy it, yeah? Okay, so let's take a look back at the notes. Sorry, let's take a look at this one. Okay, this one. Okay, wait, sorry. We will skip all this. Can you all turn to this page? I don't know what page. Page 6, everyone. Okay, everyone turn to page 6. Okay, so what is stoichiometry all about, right? So in chemistry, please take note, we are interested in how much product you form at the end of the reaction. So usually if I tell you, oh, I start with 3 grams of this, then I will want you to calculate how much product I will expect to get from the particular reaction. This is all about stoichiometry lah, in this case, right? Now, so let's take a look at this question here. I have given you the equation, nitrogen plus hydrogen become ammonia. And here, everyone please say, I start with 28 grams of nitrogen during the reaction. So there are 2 questions to this. They ask you, what is the mass of hydrogen required? And second one, what is the mass of ammonia produced from the reaction in this? You all know what page 6 okay, of the notes. Okay, all right. So usually for me, when I teach stoichiometry, generally there are only 4 steps you need to deal with in this case. So everyone, please pay attention to my 4 steps, because once you get these 4 steps nailed down, generally you'll be okay for all other calculation questions. Okay, so what is the first step? Step 1, write a balanced chemical equation. If it's given to you, good. If it's not, please go and write the balanced equation yourself. Okay, by right, you are supposed to know certain reaction. I hope you all remember like your acid plus metal, all this. By default, you are supposed to know the reaction. Okay, step 1. Now, usually for me, the other thing that I like to do in step 1 is I like to put information on my equation. What do I mean by that? If you look at this question here, I have provided you 28 grams of nitrogen, right? So I like to put the number here. At least I know, okay, what information was provided to you. All right, and what's the aim of the question? Your aim is to find hydrogen gas for the first part and the ammonia in the second part. So I put question mark on those 2 cases. I mean, like you write the balance, then you, write the balance chemical equation, then you just, whatever information you have, you just put in on your equation lah, in this case, okay? Now, step 1, I repeat, write balance chemical equation. Now, step 2, what is step 2? Step 2 is always find mole. Find mole. Okay, how to find mole? You must use one of the 5 formulas that we discussed just now. Either mass, volume of gas, concentration. Find mole. If you cannot do this, you will lose 1 mark already, because 1 mark is always allocated by using one of the formula to find mole. Now, based on the information, let me ask Isaac, what information did we provide just now in the question? The mass of nitrogen, right? So meaning with this mass, what can we find? How to find mole? Correct. Divide by the MR, right? That is the formula you need to apply. So please use one of the 5 formulas. To calculate mole. And as what Isaac told me, the formula you need to use here is number of moles of nitrogen is equal to mass over MR. Okay? So the mass I have given to you 28. MR of nitrogen, please take note, flip to your, what's the word called? Periodic table. MR of nitrogen is 2 times 40. Okay? Then you realize, 1 mole. Next. This is 1 mark by itself. Okay? So please do not waste the mark. It's easy score. Easy to score. Okay? All right, okay? Okay. Then after that, what is step 3? Step 3 is to do mole ratio. Very good. But mole ratio between who? It must be between the person you have the mole versus the person that you're supposed to find. Now, just now Isaac already told me whose mole we have here? Nitrogen. Correct? Now, what's the intention of the question? For this one, they want to find hydrogen. Oh, where's my mouse? Hydrogen. Correct? So you should do mole ratio between nitrogen, which is what you know, to hydrogen is what you need to find. So mole ratio between nitrogen and hydrogen all the time. Unknown to the, the known one to the unknown one. Always. Known to unknown. Okay, but anyway, come, continue, Isaac. How do you establish the mole ratio? What's the mole ratio? What do you look out for? How do you tell it's 1:3? Very good. This is where the balanced chemical equation become very pertinent. If you never write a balanced chemical equation, this will mess up the mole ratio. So how do you obtain 1:3? You look at the number at the front. You see, nitrogen, I didn't put a number, right? It's assumed to be 1. Then the nitrogen in front number, 3. So mole ratio, you look for your balanced equation, the number in front. 1:3 in this case. Okay? All right. So since Isaac already told me is 1:3, since we know this is 1 mole, everyone, what's the mole of the hydrogen gas then? Also 3 moles in this case. Okay. So step 3, always mole ratio. 1 times 3, right? So 3 moles. Okay, next step, what happened? The last step will be step 4, solve the question lah. Solve the question. So what did the question want you to find? Find mass. Okay, find mass. Mass, right? Yeah, correct. Mass of hydrogen. Okay, so I want to ask all of you, what is the formula we need to apply here to find mass? Mole equal to? Sorry, mole times? Correct. Or mole equal to mass over MR, right? Since I know the mole now, 3 moles, I know also the MR of hydrogen you can find in your periodic table, right? I can find the mass. So mass is mole times MR. So 3 times the MR of hydrogen is just 2. So the answer is 6 grams. That's the final answer. Okay, sorry, this one handwriting, moles. Okay. Okay, and I want to make sure you all understand this. Presentation matters here. Okay, I know some of you when you are doing more, sometimes never write all this wording, right? Please go and write it out clearly. Okay, as a presentation, because later when we're doing limiting access, things will get a bit messy. So I need you all to present your works carefully in this case. Okay, so now I want you all to try using the 4 steps. Can you all calculate for me what's the mass of ammonia produced? Can you all try? I want now ammonia. How much ammonia produced? Can you all try? Okay, using the 4 steps, same. Go and find for me the mass of ammonia produced. Same 4 steps. What's that? Yeah, yeah. 5 steps?
No, sorry, that's not the 5.
The mole, you already have it here, so you can skip step 2 already. So you can move on to step 3, which is mole ratio, to find the mole of the ammonia. Okay. Yeah, because you already have it here. One more already, the nitrogen. You already have it. So step 1 is the equation. Step 2, always find mole, right? The mole of the person that you know of, which you have the information already, 28 grams of the nitrogen, which you already did here, right? Yeah, then you can skip to step 3. Okay, all right, so come everyone, let's listen to what I'm going to say. So this one, take note, because it's part A, part B, right? You don't have to do the 4 steps again, because right, step 1 settled already, you have the equation. Step 2, you already found the mole of that person that you know of, which is nitrogen, 1 mole. Then this is where you need to apply the third step, step 3. So step 3, everyone please take note, you need to apply mole ratio. But this time around, I need to mole ratio between who and who here? Elmira, any guesses? Between Na3 and? Just one only. No, who do you have the mole currently just now? In part A, whose mole do you have? Correct. You can just use the nitrogen again, right? Not a problem. If you want to use hydrogen, can. But just be wary. If in case the part A you got it wrong for the hydrogen, then you get mistake here again. So try not to use the one that you are solving for. So what you have here is 1 more nitrogen. So anyway, what's the ratio? Sorry, the nitrogen to ammonia is 2:3. If you look at the equation, nitrogen is correct. Ammonia is 2. Correct. It's 1:2. Since I know nitrogen is 1 mole, means this one must be 2 moles at the end of the day. Equation. You see? Look at your equation. For mole ratio, always look at your equation in this case. Okay. Then from there, I can do the multiplication 1 times 2, full stop, right? That will give you the mole of ammonia. Then step 4, again, solve the question. Find the mass of the ammonia, which then again, you apply mole times MR. So the MR of nitrogen ammonia is 14 plus 3 times 1, which is 34 grams in this case. That's the answer. Okay. Can the rest of you all okay? That's the general idea for mole concept. Okay, so stoichiometry, this one I usually will tell students, this is what I call basic stoichiometry calculation. Why basic? Because there's only one thing that you have, which is nitrogen. Your job is to find the other problems in this case. So in this question, they ask you to find hydrogen and ammonia. Now, the most difficult question, which I think most of you always have problem with, is limiting access problem, right? You all have heard before, limiting access? Haven't heard? Okay, so you all must know by right, limiting access. Now, but before I continue on with what is limiting access, let me explain to all of you what it means. So the analogy that I always give to students is this. Now, please take note, your chemical equation is like a recipe. Meaning, right, for example, let's say I told you the recipe to make a cake. Okay, let me give you the example. I write here. I got no space, is it? Okay, I use this space. Let's say the recipe to make a cake is 1 egg, not 1 egg, 2 egg, plus 1 bag of flour. Yeah, I'm talking about it now. Yeah. So to produce 1 cake in this case, right? So let's say the recipe to make a cake is 2 eggs, 1 bag of flour. A very simplified version, but just for the meantime. Okay. Now, let's say now, after that, what happened? I checked my cupboard. I told you, oh, I only found 5 eggs and 10 bag of flour. Okay, let's say 5 eggs, 10 bag of flour. Okay, everyone ready? Okay, next question. What is the maximum amount of cake I can make based on what I have in my kitchen? Everyone. Two. Why 2? 5 eggs and 10 bag of flour, right? Now, can I ask all of you? Okay, let's say I push. Okay, maybe I shouldn't use 5. Let's use 6. Okay, if 6 then become 3. Okay, let's make our life easy, so that we don't deal with fraction here. Okay, why do you all say I can only bake up to 3 cakes? Because Correct. So when you finish your egg, what do we call this? Limiting or excess? Limiting, actually. So limiting is the one that we will completely use up. Then you realize, right? Based on the recipe, right? If I have 6 eggs, then how many bags of flour do I end up using at the end of the day? Not 4, but who said 3? Correct. You will end up only using 3 bags of flour. Correct. So at the end of the day, your eggs, right, completely gone. This is what we call limiting reagent. Your limiting reagent is the one that will be fully used up. But you can see my bag of flour, I use only 3. How many left over, everyone? 7. So 7, that is the what we call excess in this case. So here, the number of cakes I can bake, right, is dependent on who? Is dependent on the X, which is the limiting reagent in this case. So everyone please say now, the X is the limiting reagent. The bag of flour is the excess. And what happened is how many cakes you form or how many cakes you can bake is based on the limiting reagent in this case at the end of the day. Okay. All right. This is a very simplified version because later we're going to do mole. So mole is going to be a bit more complicated. Okay. But there are essentially 3 important ideas I need you all to take away about excess limiting question. Number 1, as I mentioned, limiting reagent is will be used up. Will be used up. The second thing, excess, as what we mentioned, there will be leftover. Number 3, the amount of products you form depend on the limiting reagent. At the end of the day, this is important. Amount of products depend on limiting reagent. Okay, Ken? Okay, so in the cake recipe, life is easy because why? You have eggs, you have flour, full stop. Okay, now we're going to deal with more. Okay, so everyone please pay attention to the next part we're going to discuss. Okay, so I'm going to use the same example, which is the nitrogen plus hydrogen. If you can find an empty space, you can find try to find one. Let me give you this example. Okay, so nitrogen plus hydrogen. Now, let's say I told you in the question, at the start of the reaction, I start off with 28 grams of nitrogen and 10 grams of hydrogen. Okay. Sorry. Anyone who cannot see my handwriting? Which part you cannot see? You see? Products. Product usually short for PDTS. Okay. Depend on limiting reagent. Okay. Sorry. Okay. Anyway, those who are done, you can copy this one. This example we're going to discuss. Okay, nitrogen plus hydrogen become ammonia again. But now I will tell you, during the reaction, I start with 28 grams of nitrogen and 10 grams of hydrogen in this case. Okay, ready for this one? Okay, so the first question I will ask students is this. Number 1, determine the limiting reagent of this question. Okay, then part B. Then, hence, very cool, sorry. Find the mass, make life difficult. Find the volume of ammonia gas produced. Yep. Yes, same. Okay, everyone ready for this one? Okay, so you can see this time round, the question is slightly different. Now, what is the difference? If you realize, right, the previous example we did, right, I only provide the information about nitrogen. I gave you only 28 grams of nitrogen, correct? But this time round, you see, I provided you the information of 2 people, nitrogen and hydrogen, correct? 28 grams and 10 grams. That is the difference. So usually, for combined science, they will guide you a bit. But for usually for pure chem, we will not guide them. They are supposed to know whether it's a limiting access problem or not in this case. So for combined science, usually they will guide you a bit. They will tell you, part A, go determine the limiting reagent for me. Okay, so let me go through with all of you how to determine limiting reagent. Generally, the steps are the same. It's just that I have one more additional step you need to take note of. Okay, so step 1, as per usual, is to write a balanced equation, right? I already write it down for you. Now, what is step 2? Again, let me ask Anaya. Do you remember what's the step 2? Just how we say, find what? Correct, find the number of mole, right? But there's something very weird, right? Can I find the mole of both nitrogen and hydrogen, everyone? Technically, can, right? And what formula we can apply here? Mole equal to? Correct. You can find the mole of both of them. So let's do this. Number of moles of nitrogen is 28 divided by 2 over 40, which is 2 moles. And the number of moles of hydrogen. Sorry, thank you. My math wrong lah. Thank you so much. Okay, 1 mole. And this one hydrogen is 10 divided by 2. Is 5 moles. So this one, something weird, right? I can find the mole of both of them. Okay, let you copy down first. Okay, any questions before I continue? No? Anyone know? Okay, now there is a problem here because why? Let's say I never tell you determine limiting region, right? There will be a problem because why? If I want to find the mole of ammonia later on, correct? Let's say I want to find the mole of ammonia. Then the question is, step 3, remember what you all need to do? Step 3 is, Chandran, is always to do mole ratio. Therefore, I need to mole ratio between ammonia and someone, right? The question is who? Nitrogen or hydrogen? Because why? Here, you see, I got 2 different moles. If I do mole ratio between this and this, 1 mole, I get 2 moles here. If I do mole ratio this, 5 mole, I will get around 4 point something or 3 point something, right? Then that means you got 2 different answers. How is that possible, right? So take note, usually for this kind of question, limiting excess, you must go and check who is the limiting, who's the excess here. In this case, you cannot use anyhow, any one of them. You must confirm whether one is limiting, one is excess in this case. So the question then becomes, how do you determine limiting and excess, right? This is the additional step you all must do here. Okay, so everyone, please pay attention to this part. So this is the additional step you need to do. Let's take a look at the additional step for limiting excess. Okay, everyone ready? Okay, let's do this. Now, in limiting excess question, usually what we will do, we will assume one person is completely the limiting reagent. So let me write here. Assume one person is the limiting reagent first. Okay. All right. Then let me ask Raphael, which one you want to use first? Limiting reagent, nitrogen or hydrogen? Nitrogen. Hydrogen. Okay. Let's use hydrogen. Raphael want to make your life difficult. Okay. Okay. It's just okay. No, I want to show the easier one, but you chose the harder one. But then fine, it's okay. It's fine. It's fine. Okay, I will show the harder one. Okay, hydrogen. Okay, let's say I assume I use all the 5 moles of the hydrogen in the reaction, right? Then you need to do mole ratio between who? Hydrogen and nitrogen. Between the 2 reactants. Because, right, remember, those are your recipe, the ingredients to make your cake. In this case, these are the ingredients to make your ammonia. Okay, so next question then. Chandran, what is the ratio based on the equation between hydrogen and nitrogen? You see? 3:1, right? Okay. Okay, now this is the part that things will get a bit tricky. So everyone, please take note. If, let's say, I use all the 5 moles of nitrogen that I calculated here. Okay. Now, Isaac, what's the math? What will we get for nitrogen based on the ratio? It will be 1.67 mole. Everyone agree? It's just 5 divided by 3. Okay? Can? Okay, now you all look at the numbers. This is what I need from the reaction. I need this amount of nitrogen. Okay? But you look at the number you just now calculated. Here. This is what I have. Correct? In my reaction. Okay? Next question. My needs, is it more or less than what I have? More. Correct. Everyone take note. Compare these 2 numbers. I need more than what I have. All right. So hence, can I ask all of you, nitrogen, is it the limiting or excess reagent? Excess. Limiting, because you need more than what you currently have in your reaction, right? So your nitrogen is the limiting reagent. That's the answer. Which one? Okay, so currently, right, my reaction, I only have 1 mole, correct? But based on the 5 moles here, I need way more, 1.67 mole, right? So because it's not enough to meet what I need, right? In this case. So therefore, nitrogen is definitely the limiting reagent because you have less than what you need in this case. That's the understanding. Now, of course, right, let me quickly show all of you, because Raphael chose the hydrogen. Let me show you all of you. What if you use nitrogen instead? You should reach to the same conclusion, to be honest. Okay, by the way, let me write here. Hydrogen is therefore is in excess. Okay, all right. That's the conclusion you can make. Okay. So let me show you the alternative answer. What if, let's say, I decide to use nitrogen as a limiting? So or here, assume nitrogen is the limiting reagent. So same thing, mole ratio between nitrogen to hydrogen is 1:3, right? Now, take note, nitrogen, how much you have in your reaction? 1 mole. By mole ratio, 3. Correct? This is, again, what I need. But if you look at the number, 5 is what I have. So need less or more than what you have. Correct. That's the answer. So you see, your need here, the 3 moles, is way more than what you have in your reaction. So therefore, this hydrogen is in excess, which is what we concluded here just now. It's the same. So whichever way you do, your conclusion should end up being the exact same conclusion. So I repeat, limiting excess are important. You must do all this to show that these are the limiting or excess reagent. And then you look like you got question. Okay, everyone, anyone questions? Limiting excess, very important. Then after that, what happened? Why is it important to determine limiting excess? Remember I mentioned, how much cake you make depend on who? The limiting or excess, everyone. The limiting. When you do all your calculation, your limiting is nitrogen. Subsequent calculation, you only use nitrogen. You shouldn't be using hydrogen anymore from my calculation. Okay? All right, any questions? Anyone? Renzo, okay? The rest of you? Okay, can follow. Okay, now let's deal with the next question. How to find the volume of ammonia gas produced? So I will give you about 2 minutes. Can you all try this one? Find for me the volume of ammonia gas produced. So follow my steps. Step 1, step 2, done already. Then step 3, step 4. Okay, please go and try. Okay. All right. Everyone okay? Okay. Let's take a look at mole ratio. Okay. So first question. My aim is to find ammonia. So definitely I must mole ratio with ammonia. Correct? Agree? So, but let me ask Raphael again. Who should you mole ratio from? Nitrogen or hydrogen? Sorry? Nitrogen, right? Because that is the limiting reagent. Everyone please take note. Limiting reagent will determine how much product you form at the end of the day, which is 1:3 lah. Sorry, 2, because of the equation, right? Sorry, 1:2. Since I have 1 mole of nitrogen, that means 2 moles of ammonia lah. Correct? Then you can find the volume. Now, take note. Let me ask all of you. Hold on. Volume. Take note. Ammonia is what? Yes or not? Yes. Then you can find or you can apply the volume of gas formula, which is 2 times 24 dm cube in this case. Okay, sorry, Ryan, what you want to ask? Yes, you must, because that is based on what you have in your reaction. Whatever we did here is all for determining limiting excess only, nothing to do with the original starting point of our reaction mixture in this case. Okay, so that's it for limiting excess. Okay, any questions so far? Okay, so that's it. I'm done with limiting access anyway. All right, so we will practice one question. Sorry, we don't really have much time, so I will do mole. Then later I will try to go through what are important for acid bases. Then you all will try the questions yourself. Okay, so later I'll pass you all the answer, but I want to focus more on mole because I know mole is usually the most difficult one, right? Acid bases generally quite okay lah. Okay, all right. So anyway, let's take a look at some questions on mole concept first. So again, flip to all the questions at the back. Can you all turn to question number 6? This one. Hey, no, sorry. No, question 6, sorry. Question 2, sorry. Two. Okay, sorry, I forgot. Okay, so can I give you all about 2 minutes? Can you all try this question? Question 2. This one, no limiting, no excess. It's just your normal stoichiometry problem. Okay, a few more seconds. All right. Okay, so let's go through the question together. Okay, so as per usual, as I mentioned, step 1 is always to write a balanced chemical equation. They already did that for you already, so settle already. Okay, now first thing first, let me ask Renzo, what information was provided to you in this question? What about it? Correct. So everyone take note, they have provided you 25 cm cube. In this case, I just write the information here. Anything else? And? Correct. So they have given you the concentration and the volume of the H2SO4, right? Now, the aim of the question is to find the concentration of the KOH or potassium hydroxide. So I will put a question mark to find the concentration in this case. Okay, so all these are the information provided to you in this question. Now, here I want to reiterate again. A lot of you will do this. A lot of you will tell me 25 divided by 24 dm cube. Can or not? Everyone? Can you divide by 24? In this case, no. Sulfuric acid and KOH, they are not big gas. Please take note. You cannot apply the volume of gas formula in this case. Okay, Renzo? What did I write? Did I write wrongly? Oh yeah, that's a typo. Sorry. Yeah, it should be potassium hydroxide. But anyway, okay, thank you so much. But okay, it will not affect the answer lah. Okay, but at the end of the day, yeah, it's potassium hydroxide. Okay, so your aim is to find the concentration of this person, right? Okay, so first question, you all can see, whose mole can you find? The KOH or the sulfuric acid, everyone? Correct, sulfuric acid. Because why? Which formula would you will allow you to calculate mole among the 4 of them here? The first one. Because they have given you concentration and they have given you volume, right? It's actually the third one. Correct. Everyone please take note. You are supposed to use the third formula in this case. They have given you concentration. They have given you volume in this case. Okay, so you can find mole. Now, but here, my warning to all of you is this lah. Is the unit of the volume correct or not? Here, 20 cm cube. No, what do you all need to do, Regina? And how do you do that? Not be careful. Divide by 1,000. So be careful. So it becomes 0.02 dm cube in this case. So a lot of you might have done the either unit conversion incorrectly or forget to unit convert. So please be careful. Okay, so anyway, based on the third formula, step 2, what can we do? Find the mole. Number of moles of sulfuric acid, which is concentration times volume. 0.02. Right? If you apply the formula, mole is concentration times volume, you should be able to get the mole of 0.020. Sorry, too much, 2 liters 0.002 moles in this case. Okay, that will be the mole. I think my math is correct. You all can double check my math. Okay, but yeah, that's the mole. Okay, step 3. Next step, Renzo. Sorry, what is the next step? Between who and who here? Correct. So between the person that you have information, which is sulfuric acid, to the person that you don't have the information about, is KOH. So what's the ratio? 1:2. So it will be 0.002 mole here, then become 0.001 mole. Correct? Okay, my math. Oh, sorry, my brain lagging already. 9 p.m. already. Again, 0.004. Okay. All right, and then last step, solve the question. Now, the question want you to solve for concentration of the potassium hydroxide, right? Now, again, if you want to find concentration, Renzo, which formula we need to apply? 1, 2, 3, or 4? 3. Because why? I want to find concentration. So, to find the concentration of the potassium hydroxide, you have the mole, which is 0.0004. Now, the volume, what's the volume they have given to you? Correct. Because 25, again, be careful of the units. It will become 0.025 dm cube, right? You must divide by 1,000. So then you divide 0.025. So your answer you will get is 0.16 mole per dm cube in this case. So the answer is A. Okay. All right. Everyone okay with the calculation? Sorry. Everyone okay with this question? Okay, please go and practice a majority of your mole calculation. If it's a structured question, it will be guided. So something like just now you all saw this question number 6, usually it will be a bit guided. So take note, like this kind of 5 marks by itself. So don't waste the mark. Mole concept is something that you all must get used to. Okay, as long as you practice not enough and then you understand what is the meaning behind mole in this case. Okay, okay. So for the next 10 to 15 minutes, let me try to pull ahead to cover the remaining part. I'm so sorry, but I would prefer to focus more on the mole because I think mole is a bit more difficult. Okay, so the rest of the things, right, I want to discuss with all of you is, of course, your acid base. So let me quickly explain what is the idea of acid base, and then I will tell you what are the things you need to take note with regards to acid base topic in this case. Okay. Now, firstly, as you all know by now, number 1, please take note. This one what page? Sorry, page 7. Yeah, okay, thank you. Okay, so acid and bases. Now, the first thing first, you all must know what's the definition of an acid. Now, acid, take note, is a substance that dissolve in water and they dissociate to produce a very, very important ion, and that ion is H+ ions in this case. You all must know this very well. Okay, so as you can see here, if you look at my example, you can see hydrochloric acid, it will dissociate to form H+ and Cl-, right? Then nitric acid also H+ plus nitrate ion. So H+, and sulfuric acid also H+. So for your syllabus, usually what are the acids you all need to know are this lah, essentially the 4 of them in this case. Okay, so you must know this acid. All right. The strength you don't need to know, is not in your syllabus, so you all can just read about it. But that is the general idea of acid. Now remember this. Why is it important to dissolve in water? In order to show its acidic property, they must dissolve in water. If you dissolve it or you are in the gas form, right, usually they cannot show acid properly. Now, let me go through with all of you. What are some acid properties that you all need to know? So let me write here, acid properties, some important points, acid properties. Okay, number 1, you all need to know is, number 1, they are sour, right? The taste of lemon is acid, is sour. Point number 2, you all must know is, they can be corrosive. Okay, number 3, they can conduct electricity. And number 4, they will turn them blue, litmus paper red in this case. Okay, that means their pH is less than 7. Any questions before I continue? So these are the properties of acids. If you dissolve them in water, these are the characteristics that you need to do. Okay, Chem? Okay, so that's pretty much it. Number 1. Now, number 2, take note, bases. What are bases? In your syllabus, usually we will say bases are metal, oxide, or hydroxides in this case. Okay, this one you all can cancel. This one don't care. Okay, they are either metal oxide or hydroxide. Now, what do I mean by that? Oxides, I hope you all remember, the charge is 2 minus, O2 minus. Hydroxide is OH minus in this case. Okay. All right, any questions before I continue? Okay, then of course you're going to ask me, what's the difference between base and alkaline? Base are all this, but take note, alkaline, they must be soluble bases. They must dissolve in water. Not all bases can dissolve in water. That's the problem. So some of the bases that alkaline you all need to know are potassium hydroxide, sodium hydroxide, and aqueous ammonia. You all need to know this. These are the common ones. Okay, and they dissolve in water to produce OH minus ion this time around. So this one a bit different. Okay, anyway, let's talk about properties again of alkaline. So let me write here, properties of alkaline. Okay, this time around, we're going to ask, anyone know what are some properties of alkaline? Bitter, sorry, just now we say, can be corrosive, just to let you all know, so it can be corrosive if it is concentrated. Okay, So like, for example, I think some of you might have experienced like cleaning agent, like Clorox or this, they are quite strong. So they can, what's called burn your skin. So that's why you all need to wash your hand. If let's say you come in contact with, let's say, Clorox or bleaching agent lah. Okay, any other properties? Anyone remember? Bitter, there's some more? Soapy, what does it say? Smell depends. Got very strong smell, to be honest. I would say, yeah, soapy, because all your soaps are actually alkaline, if you didn't know. All your shampoos are actually also alkaline. Okay? Correct. Can conduct electricity. Let me write down. And the last one, please take note, it will turn. Correct, very good. Turn them red litmus paper blue in this case. Means the pH is more than 7 lah. Okay, so those are the property of alkaline. So again, alkaline, they must dissolve in water. Then they can show all these properties. Please take note of that. Okay, so acid and alkaline roughly the same lah. It's just that one is H plus, one is OH minus in this case. Okay, good. Any questions? All right. So this one you all can take a look. This one you all can read by yourself. But there's one more thing I want to discuss with you, which are the 4 reactions that you all need to know for this topic. So this topic, make sure before you step into your exam, make sure you all know the 4 reactions very, very well. Now, the first reaction, which is acid plus metal, forms salt and hydrogen gas, right? This one pretty straightforward. Now, I usually will tell students, I will not say all metals. Everyone, please know, can you all include reactive metals in this case? Okay, not all metals can react with acid. Now, there are 3 metals that are unreactive that you all need to know cannot react with acid. What are the 3? Correct. Copper, silver, gold. Very good. So you all need to know these 3. They are generally unreactive. Any other metals, they will definitely react with the acid. Okay, like zinc, magnesium, all this, they can react in this case. All right. Okay, so that's number 1. Now, number 2, everyone please take note. Some of this information, okay, I will help you cancel. This one no need to know. This one can cancel first. This one no need to know. This one no need to know. Okay, I will help you cancel everything that you don't need to know. This one also don't need to know. Okay, combined science don't need to know a lot of information. Okay, but anyway, the most important thing is copper, silver, and gold cannot react. Okay, number 2, take note. You produce hydrogen gas, right? Now, hydrogen gas, what is the chemical test? For hydrogen gas, you must use a lighted splint and it will extinguish with a pop sound. That is the test for hydrogen gas. So let me write here, test. Oh, did I write here? Oh yeah, they write here. But anyway, yeah, that's the test for the gas. Okay, hydrogen gas, lighted splint, extinguish with a pop sound in this case. Okay, now the second reaction you all need to know is acid plus carbonate, salt plus carbon dioxide, and water. All right. Same thing, this one, don't need to know. You can cancel out this one. All right. But the most important thing is they produce carbon dioxide gas. And what's the test? You must test with your, wrong. I point wrongly. This one. You must test with your lime water or calcium hydroxide. And a white PPT will form in this case. Okay. The word PPT means what? Solids law. It's just a fancy word of saying solid. Okay. Now, this one, you all need to know the equation. Okay. So this one, I will write for you. Calcium hydroxide, which is the lime water, will react with the carbon dioxide. The white PPT, everyone please know, is calcium carbonate. Okay. So this is the equation. This is the white PPT. Sorry, let me write. White PPT. This one you all need to know by right. All right. Any questions? Everyone okay follow? Okay, sorry. Give me a few more minutes and then I'm done already. Okay. Now the third reaction is this. This one, the most important one. I want you all to put a star. And that is the reaction between acid and base, or acid and alkaline. So both of them will give you salt plus water in this case, this reaction. Now, there's a name for this reaction. What is the name? Sorry, correct. Very good. So this reaction is neutralization reaction. This one you all need to know, neutralization reaction. Okay, acid plus base or acid plus alkaline form salt and water. Now, in terms of the things that you need to know, I'm going to cancel out this one. Okay, but this one you all need to know. Put a star. H plus OH minus become water. This equation you all need to know because why? The syllabus stated very clearly they need you to know. So you all need to remember this. So the neutralization reaction, the ionic equation is this. Just H plus OH minus become water. Okay. Now, but I want to warn all of you, if let's say the base or alkaline you use is ammonia, the product you will get is only ammonium salt. Only. Okay. Ammonium salt only. Okay. All right. And the last reaction, which every year, every student will forget this reaction. This one, do not forget this reaction. And what reaction is this? Is a base or alkaline react with ammonium salt to form salt plus ammonia plus water. Every year, a lot of students always forget this reaction. Please do not forget. This is the only reaction you all learn that produce ammonia gas. And ammonia gas, how to test? Use a damp red litmus paper. It will turn blue in this case. That is the important test you all must take note. Okay. All right. Sorry, before you guys go, I got one more thing. I will move on to the next. I will let you all go already. Then I will debrief all of you a few things. Okay. That's it for 4 reactions. So please go and remember. In terms of balancing all this and writing chemical formula, this is your own job you have to do. So in terms of chemical formulas, all this, you're supposed to take the time to memorize all your chemical formulas. You're supposed to know how to write your chemical formulas carefully. Now, one more thing, pH you all can read by yourself. This one should be quite easy. Now, the last thing I want to talk about is the type of oxide. I'm done with because there's blanks here. I need to fill up the blanks. So the type of oxide, please take note. Number 1, wherever I ask you what type of oxide are you dealing with, the first thing you must check. The first thing you must check whether is it metal or non-metal oxide. Now, how do you tell whether metal or non-metal? Just refer to your periodic table. You all should know there's a staircase that separates the metal and the non-metal, right? So you all can determine yourself. Now, from there, metal and non-metal, you can further classify it down. For metal, you can classify under basic or amphoteric. Now, take note, amphoteric is the most important one because why? There are 3 you all need to know. And that is, you all know? And lead is your favorite Z, right? So zinc oxide, aluminum oxide, and lead oxide. You need to know these 3 very well, right? So aluminum, zinc, and lead. If you are not these 3, then you go classify it here. Full stop. Okay? You must be these 3. If not, put here. All right? Now, so what is unique about amphoteric is this. Amphoteric, I think I told to my students, the word amphoteric comes from the word amphibians. Amphibian means you can what? Live on land and water. So same thing. They can react with both acid and base or alkaline. That's the idea of amphibians or amphoteric. Okay? But if you are basic, basic, you can react with acids only in this case. Okay? All right. So metal oxide, I repeat, amphoteric must be these 3. Anything else falls under here. Okay? Now, what about the non-metal oxide? There are 2 also, acidic and neutral, right? Now, how do you all tell whether is it acid or neutral oxide? Anyone know? True, but if let's say I give you any chemical formula, let's say I give you H2O or water, how do you know it's under acid or neutral? Anyone know? Okay, come, my students. Raphael, you remember what I said before about this? How do you classify? Acid or neutral? You remember, Renzo? Okay, it's based on the number of oxygen atom. If there's only 1 in the formula, you fall under neutral oxide. So I repeat, in the formula got only 1 oxygen. Has only 1 oxygen. Meaning, for example, like water, NO, CO. What are the example I can think of? N2O, ClO, etc. All this formula got only one oxygen in the formula. If you got one, you fall under neutral. If you have more than one, you fall under here. You see, all the formula got more than one oxygen. Okay, let me write formula has more than one oxygen in this case. Okay, so that's it for the oxides. Okay, now before you guys go, a few things. For those at home, sorry, then you all copy down first. A few more seconds. Sorry, this one? Yeah. Okay, so before you guys go, for those who are here, anyway, if you got any questions, you all can stay back and ask. But before you guys go, a few things you all must collect from me. Number one, collect the answer for this one is chemistry. The one on this side, on your left side. And then collect the answer for the physics after that, in this case. So you should receive sorry. Okay, but you should receive 2 documents. After that, before you leave, there's some foolscap paper outside. You also can grab one in this case. Okay, it's on the table outside. So please grab 3 documents, 1, 2, and then the foolscap outside. Okay. All right, before you guys leave. All right. So that's it. I hope the lesson has been useful. Please make sure you all work whatever I mentioned just now in class. And please, and not please, sorry, and all the best for your end of year exam. Okay, those at home, sorry, wait, give me a minute. Let me, anyone still copy? Yeah, you keep everything that I gave to you just now. Okay, so before that, those at home, let me share my screen. Hold on, so that you all can scan for the answers. Where? Oh, you can take, don't worry. Okay, so this one, those at home, you all can scan the answers. You can get the answers from me. Okay, thank you. U is initial speed or velocity. Which one? The V and the U? So V is final speed minus initial speed.
So
or velocity. Initial final velocity minus initial velocity. So meaning, let's say just now the question, right? They say start from rest to 40 meters per second. Then the final is 40, initial is U rest. Yeah. Okay. Okay. So please grab the foolscap paper. Okay. Let me